this meeting is being recorded.
Thank you, Joe. Muy buenos días. Antes que nada, les informamos que se está grabando la sesión. Para quienes nos acompañan en español, justo después de este anuncio, que se hará en inglés y español, en su barra de controles de Zoom aparecerá un icono de interpretación, parece un globo terráqueo como ven en pantalla. Simplemente le da clic al icono y selecciona español como su idioma. Si no Si no desea escuchar el lenguaje original al mismo tiempo, seleccione silenciar audio original o mute original audio. This meeting is being interpreted into Spanish and from Spanish. In the event that there are any Spanish comments or questions, we invite all monolingual English speakers to also select this service. To do so, after this announcement on your Zoom control bar, you will be able to see an interpretation icon. It looks like a little world like you see on screen. You simply click on that and select English as your language. If you don't want to hear the original audio in Spanish in the background, also click on mute original audio. If for any reason you don't see the icon, simply click on more, the three dots, then language interpretation, and then choose English as your language. Gracias, and thank you. Back to you, Joe.
Thank you, callers, and good morning, everyone. I'm so delighted to see all of you here today. Thank you for taking the time to join us for our second workshop on potential updates to the Landfill Methane Regulation. My name is Joe Zhao. I am an air resources engineer at CARB, and I'm hosting the workshop today. This workshop is all about potential updates to the Landfill Methane Regulation. Before we begin, we would like to walk you through the Zoom meeting interface. As I stated in the introduction slide, the meeting is being recorded. We do hope to have an interactive discussion today. There will be plenty of opportunities for questions and discussion. The chat function has been disabled to minimize distractions. Those of you who dialed in or joined by phone are in listen-only mode. If you would like to able to ask questions or provide feedback during today's meeting, please join using the link in your confirmation email. Or you can email us at LMR address on the screen. That is lmr@arb.ca.gov. If you have any questions, ideas, or reactions, we ask that you please use the raise hand function in the meeting toolbar. Depending on your Zoom setting, this may be located in the toolbar, or you may need to click on Reactions button. When staff call your name, you can unmute yourself and begin. We ask that you give your name and let us know which entity that you are presenting. Following today's meeting, written feedbacks can be submitted through the link on LMR Meetings and Workshops webpage. The slides are available for download on that page, and the recording will be posted there later. We have planned an exciting workshop for you today. Here's what you can expect. First, we will have an operator panel discussion about best practices for landfill design and gas management. We have 5 panelists who operate public or private landfills. Join us today to share their experiences with the effective methane abatement strategies. Then, there will be a guest presentation about advanced leak detection technologies from Dave Risk at Flux Lab, St. Francis Xavier University in Canada. After that, we will take a lunch break, and the workshop will resume at 1 p.m. In the afternoon, CARB staff will present potential concepts for updates to the landfill methane regulation, with opportunities to engage throughout the presentation, followed by additional time for public feedback and open discussion, and concluding with next steps. Now I'll hand it over to Matt, who will be the moderator for the operator panel discussion.
Great. Thanks so much, Joe. My name is Matt Harrison. I'm the Chief of the Project Assessment Branch at CARB, which includes the team implementing the Landfill Methane Regulation, who's hosting this workshop, and we'll be hearing more from this afternoon. I get the distinct pleasure this morning of welcoming this panel of landfill operators who are here to talk to us about the different approaches that they're trying or how they're applying lessons learned from their research experience or other management experience. I want to emphasize that our goal in bringing this panel together was an opportunity to learn from the folks who have helped inform our own understanding of best practices and what it means to go above and beyond in methane mitigation efforts. And our hope is that this provides us all an opportunity to think broadly about how we can all work together to achieve our organic diversion targets and our methane mitigation targets. And in doing so, we'll provide a good foundation for the discussion we'll have on more specific regulatory concepts this afternoon. So with that, it's my pleasure to welcome the panel. We have Kirk Steed, who is the General Manager of Recology. We're joined by David Tu, who's the Deputy Director at Orange County Waste and Recycling. We have Warissa Nizawa, Supervising Engineer at LA County Sanitation Districts. Also, Hallie Brentley, Air Director at Waste Management. And last but not least, David Penoyer, Senior Manager at Republic Services. So I'd like to start off with Kirk this morning and give each of you an opportunity to talk about the management practices that you're most excited to share with us. After that, I'll have some questions for the panel, and I'll invite each of you to respond. And if time permits, we can also take questions from the audience. So if anyone is in the audience, feel free to raise your hand. You can keep it raised, or you can take a note of your question, and we'll bring it back up as time allows at the end. So, all right, Kirk, welcome, and you're first up.
Great. Well, thank you, Matt. It's a pleasure to join this group and share a little bit about the experiences that I've had with this topic. So, yeah, so as Matt introduced, I'm the general manager for Recology Hay Road and Recology Ostrom Road. So I'm responsible for managing 2 landfill facilities, as well as co-located compost facilities, Jepson Prairie Organics and Recology Ostrom Organics. So let's go ahead and advance to the next slide. So I know that this the focus of this discussion today is the landfill methane rule, but I think it's important to look at you know, a more broad picture when you're looking at landfill emissions. And so I'm sharing some data from our 2024 sustainability report that I think drives home the importance of continuing to divert organics from the landfill and you know, showing the impact that those efforts can have. So this is from 2023 for Recology as a whole, and on the right side of that gray bar is total corporate greenhouse gas emissions in carbon dioxide equivalents, metric ton carbon dioxide equivalents, and then on the left side is the calculated avoided emissions from recycling and composting activities. And so approximately a third of the avoided emissions are directly resulting from the composting that Recology does in the communities that we serve. And so again, I'm interested in hearing everything that everyone else has to share about best practices in landfills. But the best practice of it all is to avoid the generation of the greenhouse gas to begin with, and to capture the resource where we can. So why don't we jump into a little bit more landfill, you know, landfill gas discussion. So what I wanted share a little bit today is Recology's experience with an automated well field control. Specifically, Recology has partnered with Loci Controls over about the last year to implement their system into the landfills at both Hay Road and Ostrom Road. So the pictures you see on the slide currently is what the system looks like. So it's important to know that this is an add-on to the existing structure. You know, it's not intended to be a replacement. We still have individuals going out into the well field to take measurements and to maintain compliance with all of our regulations. However, the Loci system gives us great insight and great control, which helps us to increase the methane extraction from the landfill and in doing so avoid emissions. So on the picture on the left, I'll just run through what the system consists of. So there's on that unistrut, there's a black box. That's basically, there's a modem, there's batteries, they're powered by the solar panel mounted to the top of the unistrut. And so the modem gives you access to a cloud website that basically is the brains of how everything runs. So what does it do? The gray box located on the left-hand side of the picture, that has a gas analyzer in it. And so by taking gas samples throughout the day, as opposed to once a month, we can get a trend of what the individual well is doing. And then that's fed back via the modem to the cloud-based website. And then just below the gray box, you can see there's an automated valve. And so the data that's collected I wouldn't call it quite real time, but near real time, is used to automatically adjust that valve. And so as we go through, you know, the diurnal pressure variation and other, you know, as storm fronts come through, we're constantly able to adjust and optimize for what we want to collect. So the similar setup, the picture on the right, that's just a sentry. It's not for a well, but it's for a header, but same functionality. So why don't we go to the next slide? This is a sample of the website that Loci provided for me to be able to share. And it shows the type of data that becomes available with this system. And so you can see your total flow, you can see comparison of you know, your methane capture relative to a baseline that's been established, current, if you have a gas to electricity or other beneficial use and a flare, you can see what's going to each of those control devices. And then you can see the trend of your aggregate gas composition. So I will say, I'm sure I'll get this question. So we've had the system implemented at the two sites that I run for about the last year. And we've seen a significant increase relative to the established baseline of our methane extraction to the tune of about 25% over the baseline year to date so far. So it has a real impact on what you can pull from the well field. Why don't we go to the next slide? This is another screen from the website. So this one is particularly helpful. So, you know, you get the benefit of being able to maximize your methane extraction, but the system can also give you other operational data. So you have the well field overview, and you can see all of the individual points where you have the system installed. So if you have an issue in the well field, let's say, you know, somebody hits a header pipe and puts a gash in it, and you have air intrusion. Before, it's, you know, you're chasing it around in the well field, you're taking manual readings. we found that this visibility has really assisted with our ability to address issues that come up, repair them, and get back to operating as we want to. And additionally, so you can see on the right-hand side, we've been able to implement sensors down the well where we have had issues with liquid level. And again, it's that real-time or close to real-time data that allows you to avoid the issues that can go unnoticed when you're not, when you have to manually look at them. It's right there at your fingertips. And it really, like I said, it just helps with the overall visibility into the well field. So that's about all I have to say. If you want to go to the next one, if anyone's interested, there's a QR code, and or you can go to recology.com/sustainability. There's some more information about some of the things that I presented in the sustainability report. But that's what I had to share.
Thanks, Kirk. That's great. I certainly have a question. I see we have one from the audience too. I think in the interest of time, we will keep going and catch up with you in a little bit here. Thank you.
Sounds good.
Cool. So next up, we have David Tu from Orange County, who's going to talk to us about the innovative system concept that they are approaching down there. Welcome.
Well, good morning, everyone. It's really a pleasure to be here today. I really appreciate the opportunity to...
Oh, David, I'm having a little trouble hearing you. I don't know if anyone else is.
Can you hear me now?
Not much better. If it's helpful, we could move on to our next panelist and come back to you.
Can you hear me now?
Yeah, that's better.
Oh, okay.
Great.
Sorry.
Thank you.
Yeah, well, good morning, everyone. It's a pleasure to be here today. We appreciate the opportunity to participate in this workshop and to be able to share strategies as far as being able to prevent, reduce, and manage methane emissions within the waste sector. As mentioned, my name is David Tu, and I'm the Deputy Director for OC Waste and Recycling. I oversee the Frank R. Barman Landfill in Irvine and also manage the Organics Diversion Program for the county. Next slide, please. So this slide provides a summary of who we are at OC Waste and Recycling. Our agency has a long, rich history when it comes to managing landfills for the county. We have 3 active landfills and also 20 closed landfills. We also manage 4 household hazardous waste collection centers and also 11 franchise agreements for the county unincorporated. We also take a regional role with our 34 cities to coordinate diversion programs under AB 939 and also for compliance or for reporting purposes. More recently, we've added composting to our portfolio, which we'll talk a little bit more later on. Next slide, please. So this slide highlights key legislative changes within the solid waste industry in California over the past 35 years. And so what we've seen is dynamic shifts in the recycling markets starting in 2011, not only in California, but also worldwide with China's Green Fence Initiative and also the National Sword. With the recycling markets being imploded, we've seen a steady increase in landfill disposal and also a decrease in diversion statewide. And so consequently, we've seen more laws being passed to reverse that trend, particularly in the areas of organic recycling and also producer responsibility. Next slide, please. And so at OC Waste and Recycling, we do recognize that in order to be relevant with all these changes, our business model needs to evolve. And we know that landfilling is not sustainable. The fact is that once the landfills fill up, they close and then they become a liability. And so the approach that we've taken is to be able to view our landfills as resource recovery centers where we can build local infrastructure to be able to divert waste from landfilling. And so by not burying the waste in the first place, we can avoid the generation of methane emissions. And so for us, it all starts with organic recycling. Orange is the new green that we have come up with for our agency. And so we've established a roadmap as to the investments we're going to be making to recycle the organics into a commodity, such as compost and also renewable natural gas, rather than burying the waste. Next slide, please. So the plan is to create a circular economy that is local to Orange County. The goal is to be able to contain all the waste within our county borders. When we look at CARB's greenhouse gas emissions inventory for 2022, 30% of those emissions is attributed to the transportation sector. And so we know that by creating local infrastructure, we can indirectly reduce those emissions by reducing the transport times and also the vehicle miles traveled. And so, from our standpoint, cities shouldn't have to travel 40 or 50 miles one way in order to have their organic waste recycled. Next slide, please.
Hey, David, I'm so sorry to interrupt. I think there are still some folks who are having an issue with the audio. So I think for those of you who are experiencing that, if you can try turning it up as loud as you can for this speaker, that might help. And also, if you can turn on closed captions on Zoom, that will provide another way to track the conversation. Again, sorry for the interruption.
Yeah, I'm sorry about that.
No problem.
Okay, moving along. So for this to succeed, we know that it can't happen in a vacuum, but it does require partners that believe in this vision. And to be able to get us there, we're currently in negotiations with all 34 Orange County cities and the haulers to develop a regional approach to develop programs that will build infrastructure that will enhance recycling. Currently, we have what's called waste disposal agreements, which focuses on landfilling, and those agreements will sunset in 2025. We will be replacing those agreements with a new set of agreements that we call the WISE agreements, or Waste Infrastructure System Enhancement Agreements. The WISE agreements, they focus on organic recycling, material recovery, technology, and also automation at our landfills. Next slide, please. So this slide is an area view of our 3 composting facilities that's co-located at each of our active landfills. They were built in 2020, 2021, and 2023. And so combined, they have a permitted throughput of 700 tons per day, situated on 60 acres of land. And so from these composting facilities, we've been able to produce compost, mulch, and also compost-filled walls. The products are used by all of our Orange County cities, numerous state agencies, and also commercial landscapers. And best of all, the products that we produce, they are given away for free. Next slide, please. However, in order to really handle all the green waste that's generated within the county, we do need to build additional capacity. And so we're going to be converting our open windrow composting to covered air static piles. Design plans have been completed, and the air permit applications have been submitted to the AQMD. We anticipate getting these permits next year in 2025. And with the CAS system, it will double our throughput. And also with it, this technology allows us for 24/7 data monitoring of the piles, which also help us better manage piles and also avoid any methane emissions that could be generated. Next slide, please. As part of our next phase 2, we are also working with the Orange County Sanitation District to build a co-digestion facility at their wastewater treatment plants. We are preparing design plans as we speak to build a receiving station for commercial food waste at our landfills. And based on the waste characterization studies that we've completed, there's about 400 to 500 tons per day of food waste that is being buried that could be recovered within the county. And so the food waste that we collect, we're going to be processing into a slurry, and then it'll go into the POTW digesters, where renewable energy will be created for electricity and also for vehicle fueling. That renewable energy will also generate SB 1383 credits that can also be procured by the cities. Next slide, please. The last thing I want to touch upon is our Smart Landfill program. Though we talked a bit about our organics recycling, we still have existing landfills that we have to manage that continue to generate landfill gas. And for all intents and purposes, these landfills, they have to be managed in perpetuity. And you can only really manage what you measure. And so what that means for us is looking at our systems and being able to have real-time data that helps us make better decisions in how we implement best management practices at our landfills. So for our landfill gas collection control system at the Bowerman landfill, we have been piloting automated wellheads. It's a low-size system as well, which gives us access to real-time data. And so we know that in the past, this is much better than having a field technician that's going out there, collecting that data, and then providing to us after the fact. Next slide, please. At the same time, we're also utilizing on-site monitors that measures ambient emissions from the landfill. These monitors are located throughout the landfill, where we can observe the emissions over time and how that changes during different times of the day with different weather patterns. Originally, when we installed the system, it was a way for us to identify and quantify odors, but it has become a tool for us to also evaluate landfill emissions. And so, for example, in this screenshot of real-time emissions data that's been collected, from September 1st to September 14th, we can see that there are those peaks and valleys of the emissions coming from the landfill during the day as compared to the evening hours. We can see that the emissions can vary significantly due to weather influences because of inversion layers, also because of barometric pressures as well. And so collectively, by having this system in place, along with also the loci data in place, we've been able to use that to evaluate how effective are we operating our landfill gas collection control system. And also we can determine if wells are performing or underperforming, if a well needs to be rehabbed, or if an area needs additional wells. Next slide, please. So with that, I'm going to close out my presentation. Really appreciate the opportunity to be on this panel and look forward to the discussion. Thank you.
Thank you, David. That's a really exciting approach that brings together a lot of practices to address multiple goals simultaneously. So I really appreciate the presentation on that. Next up, we have Warissa Nazawa, who is going to talk to us about the beneficial use of landfill gas. Welcome, Warissa. One moment. Okay, actually, we are going to elevate Warissa to a panelist, but while we do that, we're going to move on, and we're going to hear from Hallie Brantley on the comprehensive approach to emissions measurement and analysis that Waste Management is undertaking.
Hi, thanks, Matt. As you said, I'm Hallie Brantley. I am an air director at WM in the Corporate Environmental Management Group, and my work is focused on the use of data and advanced monitoring technology to reduce our greenhouse gas emissions, and specifically methane from our landfills. So I want to start with just a couple of our goals for this program. We want to find, fix, and manage. We want to collect more landfill gas. We want to reduce greenhouse gas emissions, and we want to minimize aerial observations of plumes over our landfills. So if you'll go to the next slide. So for the past 2 years, WM has been evaluating advanced technologies that can measure methane emissions from our landfills. We've been running quite a large study and wanted to talk about what we're trying to achieve with landfill emission measurements. So there's 3 goals I want to highlight. Localize. So we need to find the emissions. We want to find those fugitive emissions where landfill gas is escaping. We also want to quantify. So we want to know how much is coming out. We want to know where it's coming out from and how much. And then we need the ability to deploy. So we need something scalable, accurate and scalable that can be reliably used to drive our find it, fix it strategy. If you could go to the next slide. This actually follows David's slides well. So we are also deploying fixed sensors at our landfills as part of our study. Landfill emissions are super complicated. Emissions from landfills vary in both space and time. Landfills are active construction sites that are constantly changing. And one of the hardest parts is there are many ways to measure concentration. So we can tell how much methane is right here, right now. But the hard part is, where did it come from? So how fast was it coming out and where did it come from? So we need advanced algorithms and high resolution wind and meteorology data to go from here's the methane here, where did it come from? And how much was coming out from different locations in the landfill. So if you'll go to the next slide. Again, there are many different technology vendors that are working on this problem. So it's a really exciting space to be in. And these measurements occur at we're at different frequencies, and WM in particular is evaluating them at different frequencies. So we've got continuous fixed sensors at a number of our sites. We're doing monthly satellite observations at 25 of our sites, and we're doing quarterly full site measurements at 7 sites, either using trace or correlation, or the scientific aviation, which is the bottom right picture. It's this aircraft that flies a coffee can over the site to give you a whole site emission measurement. And then we're also evaluating drone technology. So we're looking at quite a few vendors, looking at those components of quantify, localize, and deployable. If you will go to the next slide. I wanted to show just one of our example landfills, what we're seeing. So these points represent measurements of emissions. So this is an emission rate from one of our landfills over time. So this represents March 2023 to September 2024. So over a year's worth of data. The green points are a private satellite vendor that we've been using, GHGSat. The gray points are Carbon Mapper. So that is public data, generally aircraft, but Carbon Mapper has started using satellites as well. But I think this is all aircraft data from Carbon Mapper. And then the purple is those coffee can, another aircraft measurement of a full site emissions. So we're stacking them all up, and you can see big error bars. So that is often driven by wind. I mentioned you can measure how much methane is here, but where did it come from, and how fast was it coming out? You need good wind information to get that. And so when the wind conditions are not ideal, you get bigger uncertainty. So that's something we're working through as we really figure out how to use this information. But even with the uncertainty bars, we're starting to notice trends, and we're able to turn this data into action and to optimize our gas collection systems and evaluate mitigation strategies to really get an understanding of do different mitigations, how much methane are we not emitting because of different operational practices. So if you'll go to the next slide. Each satellite observation comes with a approximate source location on the landfill. So anytime we get an observation of a satellite that is a detection, they've detected methane over our landfill, they give us an estimated, we think this is the source. That is approximate. So that's one of the things we're working through is understanding the uncertainty in the location as well as the emission rate. But we are seeing trends. So those pink dots are approximate source locations of the satellite emission rates, those GHGSat observations that you saw the emission rate in the last plot. And I have listed out some of the things. What have we done? So once we got that data, what did we do with it? What did our site teams do with it? So source A, you see there's a lot of pink dots in that source A box. That was our active fill area. We saw persistent observations. So the satellite, as we were monitoring monthly, we saw 14 observations between June 2023 and January 2024. There was an ongoing GCCS expansion. We had some wells damaged due to filling operations, and there were anomalous heavy rains causing watered out wells. So all those things contributing. And so we were able to really focus on that area. And we haven't seen any more major plumes in that area since January. So all of that was concentrated in 2023. And we were able to use that data to repair our GCCS system so that we were capturing that gas. Source B and C, those boxes were not persistent. So we didn't see points in there every month. Source B, we only observed those 3 points are all from June of 2023, and it was during active construction. So the site was installing trench collectors, and And once the construction was done, we didn't see emissions from that area again. And then source C those occurred during downtime. We had some downtime for flare maintenance, and saw those points pop up in source C. And again, once everything was back and running as it should be, we no longer saw recurrent emissions in those areas. So this also allows us to quantify, right? And when we have downtime, what are the rates we're seeing, or when we have construction. So it's really allowing us to evaluate our practices, as well as helping us focus our time and resources on the strategies that are going to get us the most reductions in emissions. If you go to the next slide. I wanted to highlight some other lessons learned. So as you saw, the emission rates are highly variable over time. So I'm going to start with the third bullet here in the middle, that you really need to understand the status of the landfill. So was there construction going on that day? Was there maintenance on the flare? Having additional operational data to layer in with these aerial observations is really important in order to interpret them properly. There's also, I focused on the satellite data. There is no silver bullet or one size fits all approach. We've got large uncertainties in the satellite data that we're still working through. And the fixed sensors and drone vendors that we've been looking at, their technologies are really optimized for oil and gas, and they still have quite a bit of work to make them really useful on the landfills, is what we have found. So they're under development. They're very promising, but the oil and gas emissions are very different from landfill emissions, and the technology vendors are having to rethink some of their assumptions when they start working in the landfill environments. So we just have, there are more research questions. This is an ongoing study. We think there's a lot of promise, but we're continuing to develop, evaluate, and get to a reliable measurement of landfill emissions. Thank you very much.
Thank you, Hallie. That is a really comprehensive analysis, and there's lots to unpack there. So looking forward to the discussion later. All right, next we will circle back to Marissa Nizawa. Apologies for the technical difficulty earlier, but thank you for joining us to talk about beneficial use of landfill gas.
Yes, I thought it was just me, so I tried to access via cell phone, but then with my luck, I just know I'm going to run out of battery. So I just tried it again. It's just one of those days. Well, good morning, everyone. Happy to be here. Mine's going to be fairly short. Try to get to the point because I'm sure we're going to have question and answer section. So my name is Marissa Nizawa, and I'm an engineer, air quality engineer here at the LA County Sanitation Districts. I'd like to share our success and challenges concerning beneficial use of landfill gas. Next slide, please. So there are various beneficial use applications for medium to high BTU landfill gas. For higher BTU gas, from what we found, you can have various options like direct usage through pipeline injection. And, but the most popular one and the most common one as far as landfill gas beneficial use would be landfill gas to landfill gas to electricity. And actually, I'm looking at this one now, just out of curiosity. Anyone knows what that one in the corner means? Arts and crafts? I actually had to look it up. So I just thought that was very interesting. Something about glass blowing up and some type of kiln or some usage. And I thought that was really interesting. So one of the more common applications is landfill gas conversion to electricity. At the LA County Sanitation Districts, we have successfully implemented 2 landfill gas to energy projects, and one of which is at a closed landfill. So this posed significant challenge for us, looking ahead. As we all know, closed landfills, gas quantity and quality reduces over time. So the moment we stop placing waste in it, we can experience a significant reduction. Next slide, please. So this is the landfill gas generation graph of an unknown landfill. So as you can see, the gas quality and quantity diminish quite rapidly. And this actually surprised us quite a bit, because what we thought was that we were going to have something of a plateau at some point. But as you can see, the peak there is very obvious. That was the moment they stopped putting trash in that particular landfill. And as more and more organics are diverted from landfill, I think we would expect something that could be even sharper turn than what we're looking at here. So as less gas being generated, a lot of landfills, to stay in compliance and to finding more BTU for gas to energy facilities, we may apply more vacuum to gain additional gas, but it is a balancing act, because we found that overdrawing from waste mass can cause undesirable consequences. You can have elevated subsurface temperature and various reactions. So really, it's a balancing act. As I mentioned earlier, we are looking ahead, proactively looking ahead as far as how to deal with diminishing gas quantity and quality, because aside from one closed landfill that we have, where we already have a gas to energy project going, we also have several other closed landfills as well. But the challenges that we found is the beneficial use for ultra low to low BTU gas. There's just not enough heat in there to really find use for it. And as time goes on, the gas quality reduces, so the project will need to be able to scale down as well. So we may start off at, 1,000 SCFM of methane gas, and we're going to end up with quite a lot less. And I think the technology as it stands, we've been working with various companies and researching into new technologies. I mean, there's some promising technologies there, but I just don't want to sugarcoat anything, because the reality is that pursuing this type of beneficial use for closed landfill could be quite challenging. Just like what they said, the last mile is really the hardest. So that's what we're experiencing now. So that's all I have. Thank you.
Thank you. Yeah, that's a really interesting takeaway. I hope you'll come back and share more when you have more to share on the technologies for low BTU gas. And definitely appreciate the landfill gas and arts and crafts facilities nexus. So thanks for that. All right, last but not least, we have David Penoyer, who's going to talk to us about landfill gas design and management practices. Hey, David.
Hello, everyone. In my role at Republic Services, I'm the Senior Manager of Landfill Gas Operations. So I help our field teams with design, construction, and operations related issues. And so what I wanted to do on these slides is talk about some of the design aspects and the processes we use and the challenges for capturing landfill gas. But before I do that, I should say first, because some things I may say are contrary, may seem a little contrarian. I'm all in on methane mitigation and attacking it. I mean, from a personal standpoint, I've got vermicomposting, I've got a barrel composter in the backyard, and I recently bought a Lomi, so I haven't thrown away any food waste in a few months now. So I'm all in on it, but there are some things that as we go through this, you'll see that there could be some unintended consequences when we look at capturing landfill gas from landfills, and I just and we'll talk about those. So next slide. One of the things I always remind people is that especially our teams, is that landfills are engineered biological structures. They're dynamic, they're complex, and no two landfills are the same. And so we can't expect that the solution that's going to work at one landfill is necessarily appropriate at another one's. And for the regulatory community, we always need that flexibility to apply the most appropriate solutions. And sometimes when we talk about best management practices or design standards, we think that that's the way you should do it at every single site. It's not. There are a lot of different ways to approach and to solve problems. Next slide, please. And from an industry standpoint, I can say that from what I see out there with our peers, we keep pushing. We're not in the business to let gas get out of our landfills. It's a valuable resource. We want to monetize it. We want to reduce our impact on the communities and everything. So we continue to innovate. And for that reason, when you're innovating, you're gonna try things and they're gonna work or not work, but we don't want those to be set in stone where we're stuck doing those all the time, because we need the space to iterate and continue to evolve. So like when we're talking landfill gas, just as Hallie was mentioning with leak detection and emission measurement, there are a lot of different tools in the toolbox. So there are a lot of different ways to get at the endpoint. And I know that one of the things that CARB wanted to talk about here were some design innovations. And I'll talk about those on the next couple slides, give you some visuals, maybe not the most complicated or sexy drawings, but at least give you an idea of some of the things that we've been thinking about and trying out there. I will also mention that there's some really innovative things going on with liquids pumping for those landfills that are a bit wetter, that take wet waste, even if it's in an arid environment. As well as the renewable natural gas space, which everyone's very familiar with. There's a lot of push there to make sure we're capturing every little bit of gas that we can. I will point out in that last column there that just because you can doesn't mean you should. And I recognize that there are no bad ideas in a brainstorm, and we get a lot of them as we're trying to come up with concepts to kind of take a different approach at landfill gas collection and management. Sometimes we'll hear people talk about, putting in permeable layers within the waste mass to direct gas in a certain place. We've tried that. It's a great idea. Looks good on paper. Doesn't always work. Using an abundance of crushed concrete in certain gas conveyance layers. Crushed concrete in landfill turns into cement over time. I mean, just gets calcified and doesn't convey gas later. So again, there may be some things, and I've seen that, and with all due respect to our friends at Rocky Mountain Institute, and so in one of their recent reports, they mentioned some of these concepts that you're like, okay, I get it. I just want the audience to recognize that when we read some of these ideas, they're ideas, they may work. Some of them we've tried, and there's a reason we don't do them on a large scale, because at some point back in the aughts, the 90s, whatever, we tried these and they did not work. Certainly open to trying things again, but I did want to throw that out there. There are some things where you can have unintended consequences, and we can go down a rabbit hole that don't yield fruit. I am interested in a couple topics that it's interesting that the two of the presenters had good results with automated wellheads. We've tried those on a couple sites, and I'm a fan of the technology, but we don't see an increase overall in flow rate. Maybe it's because the landfills we've used them on are just complicated. So that's one piece of the puzzle, but you have all these other things that can go wrong or change or that are always in flux. So that one little item isn't going to get your flow to go up over time necessarily. It could, but that's not your silver bullet. We also hear some people use terms like caisson wells, like to build a well as you go up. Seems good, but if you can't keep that well under vacuum at all times, it doesn't really do you much good. And because you don't have an effective amount of solid pipe below ground to really pull hard on that well, you can get a lot of emissions outside of that. So again, when we throw around terms that we view as innovations, they can work well, but some of these can be really, really finicky, and they can have the adverse effect of actually causing more methane emissions than some of the standard approaches we use. So again, I'm not trying to sound contrarian, but I do want to make sure that the audience and the rule makers and everyone understands that there can be pros and cons of these things, and we need to make sure that we don't box people in to only use something just because we saw it somewhere and it sounded great. It may have worked at one site, but it didn't work at 3 or 4 other ones, and we don't always hear about those. Next slide, please. So again, I was tasked a little bit with talking about some design innovations or concepts, and I don't know if I'd call them greatly innovations, but just a different way of thinking about things in some cases. When we collect gas from a waste mass, usually we drill a 3-foot diameter hole into the waste from anywhere from 50 to 200 feet down, and we pull gas to that vertical column or that column of rock, or we put in a horizontal collector that may be sloped one way or the other. But because of differential settlements, those horizontal collectors, they can belly out. And once you get a little dip in those, you can accumulate liquid, and then it becomes almost like the P-trap under your sink, and you can't pull gas through those. So sometimes they're sacrificial. If you've got a really dry landfill, they can work for a really long time. If you take a lot of wet waste or other things, those may be a bit sacrificial and not long-term solutions. And so when we were looking at, gas collection, we're thinking, okay, we standing out there using our leak detection methods, you recognize that there's some ways that we may be missing gas. And one thing we thought is, okay, what if I take that horizontal collector, I slope it, and I drain all the liquid that might accumulate it into a new cell. And of course, this works for a new cell, not if you're just continuing to build up in the waste mass. But if you've got an existing waste mass, like shown on this drawing, and off to the left, you're building a new cell, I know that I can have a gas coming out of that slope because I've got perch liquid and I've got deep gas way down that I might not be capturing. How do I address it? So on the next slide, you can see that one of the concepts is that, as shown by that yellow bar on that slope, we kind of turn that horizontal collector or that vertical well on their side. And the intent here is that we're going to capture deep gas and also give liquid a pathway to move. And so on the next slide, you can see that the gray dashed lines indicate gas flowing into this collector. The blue shows the liquid draining down to the bottom. And the beauty of these is they're out of the way of operations, and you kind of build these and march them up the slope as you go. So the advantages here is they are never going to water in. We don't need pumps. They're not in the way of the filling operations. We can capture that deep gas like down at the toe of the slope that otherwise sometimes you cannot get from a vertical well drilled deep down from the very top. And you provide a passive way. We let Mother Nature do the work for us, and we get liquid out down to the bottom so gas can go up towards the top. Next slide, please. Another concept that we hear a lot about, and again, it's been shown in a few reports, is like rock targets at the bottom of new cells. And the purpose of this is we talk about vertical communication, because again, when you have this big waste mass, you're trying to engineer it so that the byproducts go where you want it. The liquid flows to the bottom and gas comes out wherever you're trying to pull it. And so by building these permeable pathways, we facilitate that movement. The problem is that usually when we drill vertical wells down into the waste, we stop 15 to 20 feet off the bottom. It's a factor of safety. We don't want to drill through the bottom. So we always leave a mass of very highly compacted, dense, decomposed waste down below that sometimes liquid can't find its way all the way down to the bottom. So even if we've got a free-flowing liquid leachate collection system at the bottom, there can be perch layers in between or above that where things kind of get jammed up. And so what we thought is, let's build a highway down to the bottom. And so we build these targets at the bottom of the landfill that connect with the leachate collection system. And then in the future, we drill down and we hit that. So now I've got a continuous vertical communication pathway for liquid to move down and gas to move up. So the great thing is these work fantastic when you do them. They're expensive. The diagram shown here shows a Gabion cube at the bottom. It's a 15-foot by 15-foot by 12-foot tall column or stack of rock. But there are other ways of doing it. And so what we found is when we initially did these at our Sunshine Canyon landfill, they were an innovation. We patented it so that we could make sure that these were always available to us. But then we realized also there are other ways to do it. I know some of our partners will stack hay bales in the bottom of a landfill, fill the operational layer up, pull those hay bales out, backfill it with rock, or they'll stack rock in other ways. And so again, the main thing is you just got this target at the bottom where you can drill down in the future to provide that vertical communication. So again, when you see the term Gabion cube, that's a generic term. There are other ways to do this, but the concept is you've got this vertical movement of gas or liquid down to the bottom and gas coming at the top. Another downside is because you've got such good communication, you've built a super highway where gas can come through. If their vacuum at the top of this is not consistent, these can be chimneys. And we saw this on some early flyovers where they were the tops of these were a little too close to ground surface, and we did not have them under vacuum yet, where there was just gas coming out significantly. So again, there are a lot of things you have to think about. And then also, of course, it only works in new cells. You can't go back and retrofit an existing waste mass to do this. So again, just some things to keep in mind, but it has been something that we've been very pleased with and utilize it in many cases. It's not for every single well, every single cell. It's not necessary everywhere, but it's an arrow in the quiver for us as we're tackling problems. Next slide. And the last one, and this is going to be like complete mad scientist stuff that may not make a whole lot of sense, but one thing we thought about also, and again, the reason I bring these up is to get us thinking. We're always trying to innovate, try to find out where are the pinch points, how do we get better at capturing gas? And so one of our ideas is when things are above ground and we're building things up, it's difficult. What if we change the paradigm and we flip everything upside down? Turn your well upside down, and instead of pulling gas out the top or the sides, you pull it down. And so we've done this at a number of sites. It's different. It challenges our designers to think differently. It works most times, but it is difficult. And I'll show you in the next couple of slides an example where we did this. But the results have been inconclusive at a few sites. And part of it's because everything's underground. You don't know why it's failing when it does fail. You can guess, you can do some investigation, but sometimes you don't know the exact root cause. And because you can end up with this super interconnectivity, that it's hard to make sure you've got the right number of collectors in the right place to make sure the gas does come to you properly, regardless of how many calculations you do. So on the next slide, you can see that what we did is in this brand new cell, I've got a bunch of little colors here. This is hand drawn. In the foreground, the green little dash lines indicate slope collectors that come up the hill towards you in the picture. On the next slide, you can see that those white little dots on the sides of the cell with lines going up the side slope, that's the beginning of our bottom-up collector. I've built a target. I've got white vacuum lines. So again, I'm going to pull gas to the bottom and out to the side. And on the next slide, you can see in this case, we did use some Gabion cubes, those gray little masses in the middle of the cell, where in the future, we'll drill down to them. And we also have some vacuum lines in the bottom of them. Again, I point this out is because there are a whole lot of different ways to skin the cat. And there are a lot of different things that we can try. They may or may not always work. And on the next slide, we'll wrap this up. I just want to leave with you guys some final thoughts that there are a lot of factors affecting whether certain concepts will work, whether they're appropriate, whether we want to box people in and force them to use it or encourage people to use it, the age of the landfill, the geometry. So, some things work in some cases, not in others. And that's where we as an industry have to be nimble. We have to look and evaluate what works and what doesn't. And we can't be afraid to try things to go in different directions to improve. I will point out, similar to what the things that Hallie was showing with the emission measurement, we've done similar things, and it's important to point out that landfills are sponges. Just because you shut off gas collection for a little bit, there's waste mass. There's pore space in there where it can absorb gas. So every time a flare goes down, it doesn't mean gas is coming out. We've done cases before where we've seen that the amount of emissions detected from all the technologies does not necessarily correlate with the flow rate of gas we see coming out at our blower stations. So again, just not to jump to conclusions, it's just because a flare shut down that you've always have gas spewing out of the hill. There is that absorptive capacity of the landfill. And the last thing I'll point out is, again, from the regulatory community, I keep coming back to the flexibility, but we cannot let elevated temperature gas sit in the landfill. If it's there, I may not want it to be there, but I got to get it out. So we need those higher operating value approvals from the state so that if we've got warm gas, we can pull it out. So over time, everything gets back to normal. I always tell people it's almost like pulling toxins out of the body. If it's there, you may not like it, but let's get it out. And so we need to be able to pull that hot gas out to kind of relieve the conditions that are inside to get things kind of where we want them in the future. So that was it. Thank you, Matt.
Great, thank you. As I mentioned at the beginning, our goal in asking you all to come talk to us today was to provide the foundation for this afternoon's discussion, but also to be able to think a lot more broadly in terms of organic diversion and landfill gas management. I think you guys have done a phenomenal job, so thank you very much for the discussion. We have some time for some questions. I have a couple questions for you guys. It looks like we have a couple questions from the audience. So I guess at moderator's privilege, I'll start. And feel free to chime in. But one thing I'm curious about is that for those of you who have piloted advanced monitoring technologies like leak detection or real-time wellhead monitoring, how have your findings influenced your day-to-day practices, and how can better data on GCCS performance inform decision-making? And maybe we'll kick this one over to Kirk because we haven't heard from him in a while.
Thank you. Yeah, so I talked about this a little bit when I was discussing the loci system, but it's just getting the insight right now, having it at your fingertips to be able to make the adjustments that you need. So, I talked about being able to trace down issues you have with oxygen in the system, monitoring water levels. Basically, you can for most of the issues that especially like recurring issues, the system can help greatly increase your visibility of those issues.
Any others? I'd love to hear the perspectives from the whole panel. Thanks.
Yeah, I would just like to add that, those familiar with the process of collecting data, right? You have a field technician that goes out there, and, depending on how many wells that you have, especially like a large landfill, it may take a couple of weeks or the whole month to be able to collect that data. And so when we get that data for our engineers, it's not real time for us, right? It's over a few weeks. And so being able to have more data helps us to really look at the system holistically. Because, when we look at these wells, we can't look at them individually, but we have to look at them as an integrated system. And so then how do we go about using that data to be able to best tune the gas collection system to either control emissions or be able to collect that for energy purposes? And so for us, having that additional data has been very valuable. And then from that, where do we also need to install some additional wells, right? Maybe there are some wells that are underperforming. And so again, having that additional data and closer to real time has been very helpful for us.
I just wanted to add one more thing. It allows the whole team to be involved with the management of the well field. You think about how well fields are typically managed. You have a technician that goes out there. They're the ones that see the on the field result or on the well field results, but they may not have the higher understanding of how the system is supposed to work. And so allowing, the engineers and the other folks that have more experience or more education on how the systems are supposed to work is overall beneficial.
Can I also just add as well, and that is a lot of the data now is now available online. And so again, traditionally, the measurements are taken with a field data sheet that has to be translated, right? And then typically it's only, looked at by the engineers, but, from a management standpoint, we can look at this, online as well, right? Real time, at least close to real time as possible. And so again, that's another tool to be able to have because it makes it very transparent as to what exactly is happening out in the well field.
And I'll chime in. The leak detection technology, so using the advanced emissions measurement, has allowed us to find issues faster and resolve them sooner that maybe wasn't apparent on the quarterly monitoring for some reason. So it's yes, we can find things faster, get them repaired faster, and also build the case if additional capital improvements are needed. It helps highlight those areas, and the need for those dollars.
Yeah, that's really interesting. So you found that to be kind of a causal relationship between the real-time data and the ability to make that case?
Yes, so not necessarily real time, but even the snapshot measurements of emissions from the site can help make that case if you have all the right context. So yeah, and there's all the qualifications of snapshot measurements, but if you have repeated ones and the right context, it can help make the case.
That's great. Okay, other panelists welcome to chime in. If not, one more question for you guys from me. looking upstream a little bit of the GCSCS management, does anyone have thoughts on how to approach selection and maintenance of cover materials to control the surface methane emissions?
Yeah, this is David too. For us, obviously maintaining the cover is going to be very important because we certainly don't want leaks or emissions coming from the landfill. And so that's one of the reasons why we are utilizing the EnviroSuite, the on-site monitors, because we would get notifications that there's maybe like emissions or there's like odors coming from the landfill. But the landfill is very, very large, right? Our landfill is permitted for 534 acres. And so, we need to be able to identify, where are those high concentrations coming from? And therefore, is it because a landfill gas issue? Is it because we have a cover issue? Things of that nature as well. And so being able to kind of pinpoint exactly where the issue is going to be important. And then once we identify, let's say it is because of desiccation, because of our cover, then we'll go back and then we'll be able to maintain. But typically we do use soil. At one time, we did use processed green material, alternative daily type cover for immediate cover materials. But we found that soil at least is a little bit better for us just because sometimes with the way PGM works, there could be a void underneath it. We just don't see it. But obviously with the soil, we do see the desiccation, do see the cracks. And then from there, we're able to go back and recover or make cover repairs.
Thanks. Is anyone using other materials? All right. Okay, I think we probably have enough time to pivot to a couple of audience questions before we close out the panel. Let's see here. First, I see Rachel Horn has been waiting patiently. So Rachel, do you want to please chime in and let us know if you have a question for a specific panelist or for the panel more broadly?
No, I don't have any questions. It must have been accident.
Okay, great. We can move on to Ruben Rodriguez.
Hey, buenos dias. Can you guys hear me?
Yep.
Awesome. It's a lot of great information, a lot of great technology. I would like to ask, can this technology be pushed to landfills that are near communities, specifically speaking on the community or the Avenel Regional Landfill? It is about a stone toss away from the community. And I'm not sure if this technology is actually used within this landfill, but is this something that can be proposed specifically for this landfill?
Thanks. I think in terms of concepts, proposals, and potential requirements under the regulation, we're going to talk more about that this afternoon, and really looking forward to your participation in that. I don't know if any of the panelists have thoughts on, the suitability of the technologies you presented for different sites and site characteristics that might make those technologies a good fit. I know, David, you made the case that there's not a one-size-fits-all solution. So again, broadly, what types of characteristics lend themselves to certain approaches?
Yeah, I apologize, Matt, if I can add to that. I believe that the reason for this question was we have a lot of complaints, a lot of reports that are coming from this community, right? And my mentality when you guys are pitching this technology, just clicks and says, well, why is this being used to help mitigate issues, right? Or help understand what the community is experiencing. There was a few pictures there that you guys showed that had multiple images or dots, I guess, representing these well finders or this, it's called a NOC tech, right? And again, just curious as to, do you guys know if this can be pushed to communities that are experiencing these type of odors?
Thanks.
Yeah, Matt, this is David. I don't think that anything we've talked about here can't be, I mean, you're right. I did say before that there's no size fits all, and you've got a lot of different options, but I don't think that anything we've talked about can be precluded from being used at any site in particular. I think that a lot of the things we've talked about are are widely understood, you know, and it's just deciding on whether it's appropriate for a certain site or provides value, right? Because sometimes you can get a bunch of information or try things that don't work, and it's like, well, maybe that's useful to prove something, but I don't think that anything we talked about today was you know, so specific that it only applies in like one little situation.
Yeah, can I also add, this is David too, and that is when I talk about the on-site monitors, you know, obviously our landfills, you know, we do have encroachment, right? We do have communities that are being built right up to the landfills. And so we felt that we really needed to look at what technologies are out there and be able to use that as a tool for us to evaluate what odors or emissions may be coming from the landfill that's maybe getting into the neighborhood. And so it's been very helpful for us. And then part of it is being able to tell the community that, look, you know, we're not just like a dump, so to speak, right? We're very engineered in what we do. And so if the technology is out there, we're going to look into it, we're going to evaluate and see what we can do to better help manage our landfills and ultimately the odors that may be getting into the neighborhood. And so for us, it's been very helpful. And then, you know, seeing is believing as well. And so it provides a level of comfort to the residents to know that, hey, you know, they made a big investment living next to the landfill, but that we're doing everything we can to best manage and minimize any type of nuisances that may be going to their neighborhoods.
Let me just add one other thing. I agree with everything that both of the Davids said. Yeah, I mean, especially when you're talking about community complaints, you know, it's got to be a dual solution. So technology is part of the solution, but being in the community, you know, committing to what you're going to do and living up to it is just as important as having a technical solution. So yeah, it's going to be a multifaceted approach, and you know, finding what works best for your specific situation, you know, will take some analysis, but yeah, there's lots of options out there.
Thank you. That's helpful. And I see one more hand up, Majid Delkash.
Hi, yeah, this is.
Oh, Majid, we're getting loud echo.
Oh, so good. I'm sorry, yeah, so we have like multiple people here. So this is Majid from US EPA, and my question is from panelists. So we have some information about like some intermediate covers that they might use like maybe sand or like maybe pretty permeable materials, and that might cause like maybe gas collection systems. So my question is from like each of the panelists, so especially like Recology or Republic Service. So what type of materials do you normally use for intermediate covers? And do you have any suggestion specifically how we can maybe move forward with this type of covers to mitigate emissions? Thank you.
Oh, I don't mind going first, Kirk. So for Republic, usually it's a mix of on-site covers, so whatever is most available. And sometimes it's just a matter of if it's not effective either as erosion control or for mitigating emissions, it ends up being a thicker layer than might be required. So I think that numerous different soil types that we use on sites, we do use transitional covers, temporary caps out there. In certain areas where it makes sense, where we're not going to go back on an area for a while. But Majid, I can't give you a specific as to this is the type of soil we always use, because it varies by site as to what's locally available, quite honestly.
I mean, I would echo that, it's what you have available. But yeah, knowing, especially for intermediate cover that's going to be there for a while and is going to be your main, one of your main protections for a well-functioning extraction system and prevention of emissions. Yeah, you want to have as low perm of cover as you have available. So knowing your sources, whether you have a borrow pit or other sources, and understanding and getting that information to the operators, because again, whoever is the one that's applying that, if they don't understand the differences or the impact of what they're applying, then you're just lost. So it's providing that information, understanding your materials.
Okay, great. I have a couple more questions. I know we're approaching time, but I'm really enjoying this. I hope others are, so I'm just going to throw a few more at you. For everyone or anyone, what advice would you give to other landfill operators that are looking to enhance their methane control practices?
I'll jump in since I guess I can't stop talking. But good extraction at a landfill doesn't just happen. It takes planning and it takes budgeting and a lot of effort. And so that's the main thing is putting in the proper effort to plan and make sure that you've set yourself up for success. That would be my main advice.
Yeah, honestly, Matt, I mean, Kurt, you said it great. I mean, that is the biggest thing. Understanding what works and doesn't. And, a lot of times, I mean, we do odor patrols for a reason. You drive around your landfill, you drive downwind of the site, and you try to make sure that you don't smell off site. I mean, if you start to detect something, you know it, and that's a surrogate for gases escaping that I need to go capture it. So being proactive, because once you get behind, it's brutal. It's brutal digging yourself out of the hole. It's expensive. It's time consuming. Everyone gets angry. No one wants to be in that situation. So you got to be proactive. And and I think that's one of the great things with, again, the leak detection technologies we use. Yeah, we've always been doing surface emissions monitoring. That's great. Love the drones. Super, like Hallie was saying, a lot of times if you understand what you're looking at, you can go find where that weakness is, and then maybe that's a low-hanging fruit, and you just keep whittling away at it. But understanding that, doing pre and post construction surveys like that to make sure that what you're doing makes a difference, and is it giving you, you're really attacking the areas that need it. I think we find those tremendously impactful.
That's great. Thank you. All right, last question. Looking down the road, say 5 or 10 years, what do you think the waste management sector will be doing differently? And what are the trends or technologies or challenges you see that inform those approaches in the future?
Yeah, this is David too. I think that for us, we're trying to turn the corner, right? We want to be able to, because right now landfill disposal is increasing, diversion has been decreasing. We want to kind of reverse that. We know that landfills have done a lot over the last few decades, but we also have been seeing increased emissions. And so again, focus on us is to be able to have organic programs where we're not creating methane gas to begin with. But the other thing about that is just cost, right? And so technology is not cheap. There's a lot of different tools out there that we're evaluating. But when you look at really disposal rates, they're very, very low. And when you want to go to a city and ask for a rate increase, it's a very difficult thing to be able to do. And so for us, we have been looking at various grant opportunities, whether it's from CalRecycle or CARB, or even from the EPA as well. And so for us, we have looked into hiring a deputy director of sustainability who's just focusing on getting grants, because we know that right now the focus is being able to reduce greenhouse gas emissions. But certainly cost is something that is a challenge for us, but we are trying to do the best we can so that we do have the best technologies at the landfill so that we can serve our communities better.
And I think that we're going to see a lot more innovation in the landfill gas design and construction sphere. I mean, we're pushing it, and I know our colleagues are doing it too. I think we're going to see that bear fruit in the next few years. I think one of the most exciting things is the renewable natural gas industry and the focus it's put on going out and capturing the gas to use it for something. And whether sites are economically viable as an RNG plant, or we start to look at other end uses, I think you're seeing that, because even in our portfolio, you look at sites and it's difficult to maybe do an RNG project. But then you start looking at methanol, you start looking at other things, whether it's small electricity generation, and those projects are great. They just don't make any money. Otherwise, we do them all over the place. But you're starting to see the threshold of the size of the site where it makes sense to do it and where people are good at going after it. That keeps coming down. So we're starting to look at really small sites for these types of projects. And that encourages everyone to be even more focused on going out and grabbing that resource so it's not venting out to the atmosphere or just going to a flare, so we can use it. We're not there yet, but we're incrementally. It's like anything. You see an evolution in the industry and we start to lower that threshold. And I think that it's also been pretty exciting too within the industry on the focus of the leak detection. I mean, we just seen like, I mean, it's great to see our sites embracing the technology to go out and be like, look, I got this little hotspot. Let's go fix it. And then you get operations to understand it. You get your, all the boots on the ground at the sites, and people are focused on that. And that's not even regulation driven. I mean, we see that with our shareholders, our board of directors. It doesn't matter. Regulations go away tomorrow. We keep doing it because that's who we are. And I think that's, you'll continue to see more and more of that in the industry.
Another thing I think we're going to see, right now we still have quite a bit of reliance on models for our sustainability reporting, for our EPA reporting, for permitting, right? We still use these models that are rough approximations. And while the measurement technology isn't all the way there today, it's getting much closer, and it's that really explosive growth. And while a lot of it's still tuned to oil and gas, they're changing their focus towards landfills. And so as we see that measurement technology evolve, I think we'll see the reliance on models decrease as we're able to actually accurately quantify emissions from the landfills on a scalable basis.
Yeah, that's a great point. Okay, terrific. I know we're already a little bit behind schedule. This has been a great conversation, and I want to be respectful of your time. But before we move on, are there any final thoughts from the panel?
No, thank you for having us. This has been great.
Great, thank you. Thank you all very much.
Thank you.
Thank you.
Appreciate you. All right, we will move on to our next discussion of advanced leak detection technologies, and I will pass this back over to my colleague, Joe Zhao.
All right, everyone. Thank you, Matt, and our panelists for our great discussion. We now welcome our guest speaker, Dave Risk from Flux Lab at San Francis Xavier University. And Dave's research focuses on advanced emissions measurements that help reduce greenhouse gas emissions. Dave has recently led a large-scale controlled release experiment in a landfill in Canada to test a range of advanced landfill methane leak detection and monitoring technologies. We are very excited to invite Dave to present his findings and share his insights. At the end of Dave's presentation, you have an opportunity to ask questions. Now, Dave, please take it away.
Okay, great. Thanks, Joe. Can you hear me all right?
Perfect.
Okay, super. So I'm from a small university in Eastern Canada, although we do have a large research team here focused on measurement of methane, and we have been working in oil and gas for 15 years, mostly on the measurement side of things, helping people understand where methane is escaping from or coming from, building inventories at the company scale, at the national scale as well. And so we've been working in the waste sector for a few years as well, and especially on advanced leak detection technologies, and I'll tell you about that today. So next slide, please. So the Global Methane Pledge, and anyways, we have lots of reasons for collecting landfill gases, and Dave Knoyer was just talking, for example, about the renewable natural gas as well. And anyways, so we need waste sector action to be able to fulfill international obligations, and then we also want to capture it for other reasons. So next, we'll click through. There's you can actually click the whole slide open here, I think, Joe. So anyways, we have in the center here, I just want to focus on some of the aerial measurements that we have, and really they've been transformative, I think, in the way that they've made people think about landfill emissions, and from space or from the sky. So whether it's Carbon Map or others, we're able to pinpoint emissions and see that emissions may be occurring in parts of the landfill that we hadn't really been thinking about. On the right-hand side, I just wanted to show what our thought paradigm has largely been. And our measurement has been walking SEM-based surface emission monitoring scans. And these are landfill areas sort of defined in these black lines, areas of parts of one landfill. And you can see what was walked. It's the blue and the green colors on the right-hand side there. But then it's those red areas that are outlined in red that are the highest emitting. And so those are the active working phase. And so satellite and aerial measurements have told us about this. Working SEM hasn't told us, or Walking SEM hasn't told us about this. And so we have decades long experience looking for emissions predominantly where they haven't existed. On the bottom left here, it doesn't matter what these different pie charts show, except for the amount of orange on them. So the orange is the active phase proportion of total emissions at many different sites that we've measured in Canada in detailed source apportionment studies. And so it's the active working phase emissions are around 60% of total, and then maybe about 79% of total is estimated by the Carbon Mapper team in a recent paper that came out a couple of weeks ago, a survey of 217 sites by aircraft. So anyways, we're catching up, and we're changing our thinking, and we have all these reasons to collect. So next slide, please. So it's useful to think about advanced leak detection technologies, and you can click through, and we'll expose the rest of the slide here. And we have measurement challenges at landfills that we don't have in oil and gas. So oil and gas sites are pretty small and emit less than landfills. So we have larger spatial scale, larger emissions magnitude, and then we have wind and gas transport complexity. So landfills are like little mountain ranges, and that complex topography creates localized wind patterns that are different on different sides of the landfill, on top to bottom. We also have heat involved as well. That becomes more important if the winds are very, very quiet. So anyways, there are different factors to consider when we're applying measurement tools. So they have to be able to work at larger scale and with this complexity. And then in that bottom panel, again, we just focus on the orange area. So we have the active area emissions. We have emissions from the well field at smaller levels, and we always have many point and area based sources active at the same time. And Hallie pointed this out as well, that it's complex emission profiles, and it's not just one thing that emitting. And particularly we have these dispersed emissions, and that's a little bit new. So most of the measurement technology we have now has been tested on point source emissions, as though the gas was coming out of a pipe, as it often does in oil and gas. But with dispersed sources, it will come out from a broader area, and that really stretches the capabilities of satellite and aerial imagers, and basically it thins out the emissions to the point where they're not as easily visible. So anyways, we need to keep moving measurement technology along, because it's useful to help with collection, help do stock take, where we could collect better, what's emitting, rapid response, and there are pressures to have inventories done as well. So at any rate, there are lots of measurement challenges in this space. Next slide, please. So the best way to assess the measurement technologies is to not just put them in the field, but to put them in the field at a site that tests them at a realistic scale and for the real job. And so we have a simulation facility that we've built in Southern Ontario. It's very close to Detroit. It's just on the other side of the border. And it's at this location where we're doing experiments to test some of the advanced leak detection technologies. And I just thought it's useful to mention this site, because it's been important in helping us understand the applicability and sensitivity of different measurement tools. And so we began working at this site in November 2023, just before, actually. We call it SimFlex, a simulation facility for landfill emission experiments. It's a closed site, a closed landfill. It's nicely grassed. It's been closed for, I think, 6 or 7 years now, and it has a very good cap and a good collection system as well. So there are virtually no emitting points on the surface of the landfill, and some around the edges. And we have a system of pipelines and release nodes from which we can emit methane that we bring to site in a tanker truck. And our emission release area is defined by that red dotted line. And so we have 10 points active. We had 10 points active in November 2023. And we just finished a set of experiments again in November 2024 in the same general area, but with points located in different parts of the landfill. And in 2023, we had a capacity of 300 kilograms an hour, and we were able to up that capacity recently. And the system is underground, it's buried, and so we can come back to the site and turn it on and re-energize it for subsequent sets of experiments. And we find that vendors that are coming to site are really improving and learning a lot about their technologies as they do this test work, basically. So we'll go to the next slide, and we'll flash through the next few slides pretty quickly. So this is just a view of the site. It's as I said, it's a nice grassed area, and we have just some surface cuts in the soil where we have pipelines and release nodes, and particular dispersed release nodes. Next slide. So these dispersed area release nodes, they get cut into the ground and might occupy the footprint of a house. And so these are some dispersed release zones being installed before grass regrowth. Next slide. And if we zoom back a little bit, you can see how we have basically release elements across the landfill here. Next slide. So in November 2023, we brought numerous participants, numerous vendors, and research labs to site. We basically divide the types of technologies that we have been evaluating there into two different camps. There's the quantification camp and the detection camp. So some vendors and technologies can quantify, that is to measure the actual rate of emissions, and others can detect. And so that's more typical of SEM, for example, of walking SEM. So just a detection, it's not a rate quantification. So when we're talking about quantification, we mean to be able to determine emission rate. And so some are able to do both. And then we also have an R&D category where we have early stage participants that aren't really ready to sell anything or ready to publish papers, but they're investigating, gas transport and the applicability of different sensor systems at the site. So we use a protocol for experiments that we conduct at the site that we borrowed from oil and gas evaluation facility called METEC in Colorado. And in November 2023, we did 71 blind experiments where they didn't know how much we were emitting or what release nodes the gases were being emitted from, and it was their job to try to find it and to quantify it. And so we had drone point sensors and column lasers. I'll talk a little bit more about some of these individual methods as we go on through the talk. Aircraft mass balance, where we fly this coffee can approach, I think Hallie referred to as the coffee can, and some truck methods, including tracer correlation, which has been used a long time, and a satellite, a LiDAR team, and various other things. So there is a report from this work, and it's available at the QR code at the bottom right if you're interested to read that, and it's on the EREF website. So next slide, please. So I'll flash through a few of these plots because they're interesting. I won't show every plot from our recent round, or our November 23 round of testing, and we're currently evaluating the submissions, or receiving submissions and evaluating the submissions from the vendors from the 2023 campaigns. But what we have here are parity plots where we have the estimates of the vendor on the y-axis going up and down, and then the known release rates. So basically everything that we're releasing at this site is coming from our release system, because on the top of the landfill there are no emissions, and we've managed to verify that with walking sims and other tools. So at any rate, the tracer correlation, long time gold standard for landfill research. It takes quite a bit of time to set up. It involves releasing acetylene from usually the top or close to the center of the landfill, and the acetylene is released at a known rate, and then it gets diluted as it moves downwind, where it's detected by an analyzer, and that analyzer is also measuring methane at the same time. And so because we know the dilution from a known emission rate of the acetylene, we can apply that to the methane we measure downwind, and then we can figure out what its emission rate must have been. And so the truck-based tracer correlation worked really, really well. So you can see that the black line is perfect correspondence, the black dotted line. And so most of these green points sit basically right on top of that dotted line. It's like a very slight tendency to underestimate. So you see the green dotted line, that's the measurement bias, which is very, very low in this case. And most of the points are clustered really close to the one-to-one line where we have the perfect correspondence. So this is a very good tool. So the other plots I'll show are, somewhat less good. This is considered the gold standard, and it's probably not scalable easily at the commercial level, but it does give us really great reference measurements. So next slide, please. So we had a couple of truck teams using similar approaches broadly. The truck teams were stretched a little bit in that they couldn't do their regular work practice. The experiments were too short. Oftentimes they were just passing through the plume once when they normally like to do it about 10 times. So we expect some increased variability, but what was really interesting with the trucks in particular was this sort of tendency to be too conservative on the estimate. So you see that the release rates of the truck, or the estimates of the truck, the vendor estimates were lower than the release rates. So we had an underestimation bias by about 40%, which is very similar between the two teams, even though they were independent and doing their work separately, different analyzers and slightly different processing techniques. The results were very, very similar. And so that was really interesting to us. So we have a bit of a systematic underestimation bias, but at the same time, this is a very inexpensive and very applicable kind of technology for quick measurements. And so it can be done in an hour and a half, whereas it takes several days to do a couple days maybe to do a good tracer correlation measurement. Next slide. So this is a LiDAR system. This is mounted on the bottom of a helicopter, and the LiDAR basically takes a picture of the ground that shows the invisible methane being released from different points, and that the whole site scan can be done in only a few minutes. So their work takes normally less than 10 minutes for a small area like we were emitting from 20 acres in this case. And so we have two different colored lines here, and this is interesting because the LiDAR team originally submitted the blue dots to us, and they sit a little bit above the one-to-one line, obviously. So there's an overestimation bias. And it was part of our protocol to give teams the wind measurements from the site. So of course they're flying to site with the helicopter. They're not taking off from the helicopter every day. They don't actually know what the winds are on the ground. And so the helicopter team is using a wind product, a wind estimation that's modeled, and so they don't actually have the ground values. And so we gave them the ground values, and they adjusted their emission rates, and then we have that kind of orange line. So they resubmitted their values and came closer to the one-to-one line. So this told us that, anyways, LiDAR is working well, and it works even better if we have on-site data, on-site wind measurements, pretty obviously, because that landfill complexity can be hard to compensate for. Next slide, please. And so these are some UAV measurements where the UAVs are flying downwind, transects through the plumes, and both of them had relatively little bias, but especially on the right-hand side, we see there's quite a bit of variability. And so although the average line sits right on the one-to-one line, any measurement might be quite a bit above or quite a bit below the actual. So we would have to repeat this kind of measurement multiple times to get that correct average, because we couldn't depend as easily on any single estimate. But overall, the technique definitely works. Next slide, please. So this just tries to sum up the results from many of the measurement teams. So I have on the sort of towards the left-hand side of this plot, I have that vertical black line, and that shows 0% measurement error. And in the gray vertical bars on each side, we show what I'd sort of expect generally from first-order decay models that would predict methane emissions from landfill sites. So those first-order decay models I think in general, we're probably between 50% error and 200% error. Of course, we can have lower error than 50%, but I think if we had lower error than 50%, we'd be very proud of ourselves and doing really well. And then certainly we've seen lots of papers where for sturdy decay models were an error of more than 200% as well. But I think that those would be my general estimates of what we'd expect there. And we see that a lot of these quantification estimates are probably even better than the models. They're not perfect. Some of them fall right on that 0% line on average, and then most of the other ones are offset a little bit, either overestimating or underestimating. But in general, many of them, like 10 out of 11, had less than 50% bias, and so that was actually pretty good. I was a little bit surprised how well many of these tools worked when we had them on site. And then we see the fifth from the bottom is the tracer correlation. The blue near the top, where they sprawl all over the place, those are some of the tripod-based continuous systems, and they're probably not quite ready for prime time for landfill sites. They're developing algorithms right now, and so that's a type of technology that I think we'll see perform better and better every time we do these experiments. Next slide, please. Looking at some of the SEM type results where we're focused mainly on detection, the vendors were trying to report back on where we're emitting gases from, and so the LiDAR couldn't fool that team, so they had 100% true positives, no false positives or false negatives. And some of the drone sensors, so these drone column sensors, they bounce a laser off the ground, and some of that laser energy is absorbed by methane that might exist in the laser's path. They had quite a number of false positives and also false negatives where they're interpreting emissions that didn't exist or detecting them at the wrong locations, and a small number of true positives. And anyways, if we, one more click here on the slide, will show the work practice is probably the issue for some of these drone column sensors. So they were brand new, and they were emulating walking SEM surveys at 30-meter grid spacing, and that probably wasn't a very good choice for them. And we worked with some of those teams this year, and they've substantially changed their work practice and departed a lot from EPA 21 walking surveys, and their results look much different from just a few weeks ago. And I'm excited to see how they turn out in the formal sort of like judge. We don't really judge them, but once we do the evaluation as described in the protocol. And it brings up a question of how would EPA 21 walking perform if we applied it in the same context? How successfully would it find leaks? And I did actually a lot of the SEM surveys, walking surveys myself at the recent controlled release experiments, and I can say for sure that I was detecting fewer 500 ppm anomalies on the ground than some of the other teams were detecting. So there's results to come soon. Next slide, please. So the next steps are to continue repeating these experiments, each time with a bit of a different focus. We have a campaign coming up in the spring, focused very much on satellite and aircraft imagers and other aircraft technologies. And we will include other things, but that's really our focus. And we're also developing an adjunct site where we can be on the pipeline grid, and where some of these experiments, a small number or class of these experiments will be a little bit easier for us. So next slide. The really interesting thing as a research team is trying to figure out why things didn't work. So we were one of those truck participants that didn't, that had high variability, didn't do well. We thought it was our method, and we kept working on the method, changing the input parameters, and there was no clear input parameter winner. But when we plotted some of our values spatially, it was really interesting because the landfill is marked in blue there. Whenever we were measuring across this forest, we would underestimate. And generally, when we were in other areas, we were getting the right numbers. And so it tells us a lot about the impact of different terrain and topography on plume detection from trucks. Next slide, please. We also worked quite a bit, as I said, with the drone column sensors. And so this is a sort of simulated plot, 23 kilogram an hour release during the controlled releases last November. And this is what the plume would have looked like on the ground that they were trying to detect with the dots indicating the 30-meter walking increments. You can see from the scale bar at the right-hand side that the maximum concentrations as they would have intercepted them are only 190 parts per million, even though 23 kilograms an hour is a fairly large emission. And so their new work practice involves faster measurements. Instead of 1 time a second, they're measuring 10 times a second. So they're also flying faster. They're flying much tighter than this grid. If you just click once more on this slide, they're flying 7.5 meter grids, closer to shown here. And then if they detect higher levels of higher concentration levels, they're going back immediately and doing a micro 1 meter microgrid, sort of 1 or 2 meter resolution survey. So they're really like mapping out the whole plume. So rather than just hoping for detections, which they might cross a plume in just the right spot or not, they're actually trying to use indications to go back and to do sort of a nested sampling approach, and that seems to work really, really well with these drone tools. Next slide, please. So we've also been starting to test walking SEM. I talked about the gaps in coverage, that we can only really cover the intermediate and final cover areas of the landfill, and that these red highlighted zones, the active working face, are typically unmeasured. So these are just some examples on the left-hand side from landfill measurements we've done in Canada, where we had professional SEM contractors come in and help us, but they of course weren't measuring some of the emissions we're really interested in. Next slide, please, or next click. And so we, as I said at the beginning, we have this active working face sort of surprise, and I think there's lots of focus now on how we can collect in the active working face a bit better. Next slide, please. From walking SEM, just to go back to some of these simulations, it's really interesting to do these maps, because we can actually simulate the walking path and see what the concentrations are as we would have hit them at different distances from release points of different magnitude. And so you can see in this case, we have these large plumes, but we're only ever detecting up to around 150 parts per million. And a good SEM operator should take that and look upwind or to the vegetation stressed areas and walk to those and find the source. But somebody also working to rule and trying to get home for the end of the day might just be walking straight lines. And so it's a huge human element to some of these SEM walking surveys. Next slide, please. And so I think that compared to the walking SEM, I think that a lot of these advanced leak detection opportunities are really coming online. Some of them are not quite ready and still developing, but there are a lot of good choices as well. Sorry, my fonts are a little bit different here. I think the Mac to Windows is working on this deck a little bit, but I have a number of the types of technologies or methodologies that we've tested down the left-hand side here, and their readiness and resolution and cost and coverage, whether it's partial coverage as in walking SEM, or whether it's complete coverage, like they can cover the active working face as well. And there are many of these advanced leak detection opportunities that can provide complete coverage. And so if we did have active working face collection systems, we would be able to anyways to find out parts of that area where we weren't collecting as effectively. And so that could be used as operational intelligence for folks with collection systems in the working face. And many of them quantify as well, and that's really helpful for ranking, prioritizing repairs. So we don't want to repair the small things first, we want to repair the big things first, obviously. So we have a spreadsheet actually from doing some studies for EREF recently, or some review for EREF, and there are at least 98 different ALD tech vendors and methodologies available right now in the US. So lots of them available, from some from oil and gas and some landfill specific. And then next slide, please, which I think is the last one. So I think one of the challenges that the regulator needs to think about for rules is how to expand from walking SEM into allowing alternative leak detection. And so in oil and gas, we have in the US a matrix-based approach where we have this relationship between frequency and frequency of application and resolution. So a tool that can't resolve emissions at a low level needs to be applied more often, because the benefit that comes from that measurement will come if we can turn off the big sources that it will detect earlier. And if you detect with a very fine resolution tool, you'll have a really long repair list that you have to take a few months to work through. So they need to be applied less frequently. And so oil and gas allows flexibility for operators to use what they want. And these matrix-based approaches were built using a type of modeling called effectiveness modeling, where basically sites emit at some kind of, are simulated to emit at some regular interval, and then we apply at some interval a measurement tool, and the measurement tool will or won't detect based on its minimum detection threshold. And these models are probabilistic, and they can be applied to landfills too. And we're beginning to do that, because I think that this type of approach does make a lot of sense in oil and gas and provides a lot of flexibility. It doesn't point to really specific technologies, but points to resolution categories, and then there's an approval process that occurs to basically to meet or to be ranked into one category or another. So last slide, please. And I think that's it for me. So if you'd like to contact us in the lab, or if you're a measurement vendor, I think we don't have a lot of measurement vendors out there, and you would like to take advantage of the upcoming experiments at the release site, let us know. And if you'd like to check out our LinkedIn, or there at the top right. And I just want to thank EREF and WM, especially for helping facilitate some of this advanced leak detection technology testing, because I think it's really important for the sector right now. Thanks very much.
All right. Thank you, Dave, for your great presentation. Now we can take some questions. Please raise your hand and the CARB staff will call your name. I see that first we have a question from Catherine Bluevillet. Catherine, if you get an unmute function from the staff, please unmute and begin.
Great. I think that worked.
Perfect.
Thank you for the presentation. I just, because I didn't quite see it on a slide, wanted to ask what I thought I heard you say, which was today, the technology, the alternative technology you presented outperforms the walking surface emissions monitoring you also did. Can you just help me see the comparison and speak to how work practices, obviously, when it comes to getting those advanced alternatives ready, need to be in place?
Yeah, I said it, but I didn't say it. I tried to say it softly, because I think that we definitely have evidence now that the walking surveys, well, we know for sure that they don't cover the whole site, and we know that that the active area is a gap. I think in terms of their detection performance in controlled release experiments against other leak detection technology, last year we were not able to do walking SEM at the controlled release site for various reasons, the most important of which was the fact that we had a surface pipeline network, and our permits didn't allow us to walk in and around the pipelines when they were energized. And this year, with buried system, we were able to do extensive SEMs, and straight up through all of the SEMs we did, we only had one positive indication, despite the fact that there were definitely a lot of leak sources active. And I think that a lot of the drone results from last year were attributable to the fact that they were following the same work practice. And so that spacing is very wide. And if an emission's made in between the 30, or if an emission occurs in between the 30 meters, but by the time it gets to the area that was actually covered, concentrations will be way lower than 500 ppm over 10 meters, unless the source is really huge. And so So basically you have to pass right over it. And so if you pass right over it, you might detect something really small, or it might be something really big, but it's like really probabilistic, and it's really dependent on human strategy, human dimension. And so I'll have in very short order, I think early in January, some more definitive statistics, but I think it's interesting to examine that technique at a site like this, and I think it's a fair comparison at a site like this, but I do think that we'll probably see that it doesn't perform as well, not as sensitive. The resolution is lower than many of the other available tools right now.
Thank you. I'm just sitting with that one detection. Okay.
All right. Our next question comes from Nathan Waggle. Nathan, please unmute yourself and begin.
Hi, can you hear me?
Perfect.
Perfect. So I noticed, and I might have misunderstood it, but it looked like there was a lot of maybe false positives using the LiDAR equipment on the drones. Am I correct in saying that?
So the LiDAR was on a helicopter, and the LiDAR had no false positives. The drones had many false positives. So the LiDAR, they work differently. The LiDAR takes an image that has many pixels in it, and so they can really see every part of the site to probably 10 centimeter resolution or something like that. And they sent us pictures of all of the releases, and that was very interesting. And the drones, what they're doing is they're emulating the surface walking. They have a narrow laser that bounces off the ground and back. And so they don't measure pixels, they really measure at a point underneath the drone. And so they're flying on these 30-meter grids. And so they're basically just emulating the walking surveys. And so what was happening often for them is they said, oh, we see an elevated concentration here. And they said the leak must be right here. But what was actually happening is the leak was coming from upwind of that location by meters or tens of meters. And so that they may have detected an emission, but because it was reported in the wrong spot, it came up as a as a false positive. So because we weren't emitting in that location, and so that was the problem. So if that were a human would have been able to recognize to walk upwind and look for the source. And so it's not a successful practice to just stuff new alternative leak detection tools into an old work practice. And like I said, those drone sensors were brand new when they were used in November 2023. And yeah, we've had a lot more experience with them in just a year. And this new work practice that they're doing, which is way faster and narrow spacing, screening, and a nested approach, is just much more suitable for that type of sensor, and generates much higher resolution. I think we'll see them perform closer to the LiDAR systems this time around. Just from looking over their shoulder, that was my interpretation, is that they were doing a very good job.
So in your opinion, do you think that could have been improved upon by using a ground-based rover instead of a flying drone with already proven technology?
So ground-based rovers do exist. We haven't had any on the site. That would be interesting to include, I think, in an upcoming release experiment. I think it really all depends on the spacing. I think the key is to have narrow spacing, because dispersion is so effective. So especially if we have small emission points, the dispersion of gases in the atmosphere is very, very fast. So within 5 or 10 meters, the concentrations are often much lower than the thresholds that we've prescribed in rules. And so if the ground-based sensors that are moving can cover a narrower spacing, I think that's really the key. The sensors are near as good actually on the drones as we'd use for walking SEM actually. And so it actually didn't come down to the quality of the sensors. It really, their performance I think really came down to issues around spacing and It's just much more likely to catch smaller things or things on a more repeating basis if you're doing narrower lines.
Okay, thank you. I'm gonna send you an email after we get off of here with some more
Sure.
information.
Yeah,
Thank you.
thanks. These are all great questions. Thanks, everyone.
Great. Thanks, Nathan. Next one, we have a question from Ruben Rodriguez. Ruben, you can unmute and begin.
Awesome, thank you. Dave, I know that during your presentation, you mentioned that the LiDAR was mounted on the bottom of a helicopter. Is this something that, or is the technology advanced enough to be able to maybe install this on the bottom of a drone? I know to fly a helicopter, I would imagine it's a lot more.
I know we're working on drone systems, and LiDAR it's just a much bigger, more complicated type of sensor than these small laser sensors. So it needs to pulse radiation, and it needs to do that, to send out a beam over pretty wide swath. And it was just hard to get it down to the flyable level, but it's getting close actually. And so I think that we will see that in the future. The scans that they're able to do from the helicopter are extremely fast, and so and also extremely precise. So they were able to nail every emitting node down to 1 kilogram per hour. It's very sensitive from and only a 10-minute scan across the whole surface of the landfill. So they're very effective. It's not cheap to be able to order an aircraft to site for only 10 minutes of work or something like that. They need to spend a day. So if they can partner though with other projects that are in the areas, those are very effective types of measurements, and that's a technology that's used very extensively in oil and gas. And in Canada, for example, we do measure something close to 10,000 sites annually using LiDAR to help develop a national to validate our national inventory, basically.
All right. Thank you, Ruben. Dave, I do have a question myself. I wonder, when you guys are doing the tracer release using the truck, like, did you put the tracer release location just very close to the actual location, or you just put it like a random location on the landfill surface, which itself can be quite big?
That's a great question, because the quality of the tracer correlation measurements are related to the placement. So that the tracer needs to be placed near areas of emission of methane emission. And so when I can say in this case, because they've outed themselves as Florida State University was doing those measurements, and they did not know exactly where all the releases were at the time they placed the acetylene. And we were definitely knowledgeable about that limitation of the technique, and we try to know exactly what the limitations are of the techniques before they come to the site, so we can design experiments that are going to challenge them. And so we put some of the larger release nodes on either side of the site last November. And of course, they didn't really know where we'd be emitting from, so they put the tanks in the middle. And regardless of whether we were leaking from this side or from that side, or from both sides, they actually did a good job in all cases. So there was no systematic difference that we could find in the relationship between their overestimates or underestimates and the location of the releases. So that was really interesting, I thought. So that technique was more tolerant to errors in placement of the tracer than I expected it to be.
Yep, that's good to know. Okay, seems like we have received a question from email. This is a question from Majid at US EPA. Are they working on converting methane flux to concentrations above the ground, e.g. SEM? I assume this is probably for the drone-based measurement.
They are. So I know that there are various groups have been working on algorithms to quantify using drones. We've been working on some as well. And anyways, we'll apply some of those to data sets that we can get from the participants this time around. And we'll see how well they work. But I think that those are developing, and theoretically, those drones are making the same type of measurement that we make from aircraft or satellite. They're making a column integrated measurement. It's the same thing. And so it's just closer to the ground. And so we have many proven gas transport algorithms that would help us measure emission rate from a type of measurement like that. They've been used in the air and space community for a while. So it's just a matter of adapting that in the right way to the drone data set. So I think that over time, we'll be able to do that. Even walking sim, we can adapt that as well to emission rate measurements and estimates. There are ways to do that. So we can incorporate quantification into almost any type of measurement, or we will be able to.
Right, Dave, can you elaborate on, I guess this is, it's more geared towards the comparison between, the drone-based measurement, which is a column measurement, right, against the traditional method 21, which you measure concentration on the ground surface. Basically, can you elaborate on the challenging of converting, between the ppm you measured on the surface versus either you measure a flux of ppm meter, or let's say a total flux from the landfill, like kilogram per hour, or vice versa, I guess.
Yeah, so that's a great question, and that question gets caught up a little bit in our traditionalism around using concentration thresholds as our indicators. And so I would basically say that the column methods aren't as well suited to that kind of measurement, because or to direct equivalency to the ground-based measurement, because the methane could exist of course, in any part of the column, whereas the walking sim generally, finds things that exist on the ground and are coming from the ground directly underfoot in that spot. So I think it's we can spend a lot of time trying to develop equivalencies, but it's ultimately better to let these drones mature a little bit to the point that they're also able to quantify every source. And ultimately, it's those rate measurements that are way more useful than the concentration measurements, because we can have high concentration measurements for various reasons in walking surveys. Low wind, because we're really focused on a very small hole. It's not a dispersed emission, whereas really it's the rate that we're worried about. We're worried about how much is actually being emitted, not what the concentration is, like right at the ground surface. So I think that ultimately the techniques, methodologies that allow us to measure rate help us to better prioritize leak detection or sort of repair of leaks that we observe, because we always want to fix the largest emitting leaks first.
Right, that's great. Thank you. Okay, as of now, I do not see additional questions. No more raised hands for now. Well, thank you again, Dave. Thanks for, the interesting and wonderful presentation and the Q&A. This concludes our morning session. We will take a lunch break and be right back at 1 p.m. Thanks, everyone. See you in a bit.
Thank you, Joe. Muy buenas tardes. Para quienes no nos acompañaron en la sesión de la mañana, Esta tarde también se ofrecerá interpretación entre inglés y español. Para aprovechar el servicio, después de este anuncio en inglés y en español, aparecerá un icono de interpretación en su barra de herramientas de Zoom en la parte inferior de la pantalla. Simplemente le da clic y selecciona español como su idioma. Si por algún motivo no ve el icono, simplemente presione los puntos suspensivos o más, luego interpretación y luego su idioma. Por último, si no desea escuchar el original en inglés de fondo, también seleccione silenciar audio original o mute original audio. We are interpreting to and from Spanish. In the event that there are Spanish-speaking comments, you can hear them interpreted back into English simultaneously. To do so, all you'll need to do after this announcement is look for the interpretation icon that will look like a little world as you see on screen, and click on that and select English as your language. If for any reason you don't see the icon, you simply press the three dots, more, then language interpretation, and then choose English as your language. Gracias, and thank you, Joe.
Thank you, Carlos, and welcome back to the afternoon session of the LMR workshop. Before we begin the CARB staff presentation on potential concepts for updates to the landfill methane regulation, let me first take a moment to introduce the amazing LMR team who have worked tirelessly to put this workshop together. Again, I'm Joe Thao, Air Resources Engineer at CARB. I will hand it over to our branch chief, Matt.
Hey everyone, Matt Harrison, Chief of CARB's Project Assessment Branch, which includes this excellent team of staff who implement the landfill methane regulation. And I'll turn it over to the manager of that section, Antti Alexiadis.
Hello, everyone. Thanks for being here today. My name is Antti Alexiadis, and I'm the manager of the short-lived climate pollutant policy section.
Hello, everyone. Thank you for attending this workshop. We worked really hard on it, and my name is Sean Pinnell. I'm a air pollution specialist here at CARB, and I assist and to support the landfill methane regulation team implement the reg. Thanks for being here.
Hello, I'm Lori Gilbert, and I'm working with the landfill methane regulation team as an air pollution specialist at CARB also.
All right, and I'm Quinn Langfit, a methane policy strategist at CARB and the lead staff for these potential updates to the landfill methane regulation. As a quick reminder, this workshop is being recorded. Before we begin, we'd like to walk you through the Zoom meeting interface again for anyone just joining us. We hope to have an interactive discussion today, and to that end, there will be plenty of opportunities for questions and discussion, both during the presentation and after. The chat function has been disabled to minimize distractions. For those joining by phone in listen-only mode, or for anyone experiencing technical difficulties during the workshop, you may email questions or comments to the email address on the screen. That's lmr@arb.ca.gov. If you have any questions, ideas, or reactions, we ask that you please use the raise hand function in the meeting toolbar. Depending on your Zoom settings, this may be located directly in the toolbar, or you may need to click the reactions button. When we call your name, you can unmute yourself and begin. We ask that you give your name and affiliation. We will be taking a 10-minute break midway through the presentation so people can stretch or use the bathroom. Following today's meeting, written feedback can be submitted through the link on the LMR Meetings and Workshops page through January 24th. The slides are also available for download on that page, and the workshop recording will be posted there later. The slides are also available in Spanish on that webpage. We'll start today's presentation with some context, including background information and the status of landfill methane policies and regulation in California. Then we'll broadly discuss the goals and scope of potential changes to the landfill methane regulation that are driving our concepts. Next, we'll provide an overall high-level summary of the concepts. After that, we'll get into the details of our concepts. We'll be pausing frequently throughout this section to get feedback while each concept is still fresh. Finally, we'll end with an opportunity for additional discussion and feedback and provide next steps. So starting with background information. First, we want to give you some background about the greenhouse gas and short-lived climate pollutant policy framework in California. Over the years, California's legislature has enacted several key greenhouse gas and methane emission reduction targets. California's leadership started with the passage of the Global Warming Solutions Act, or Assembly Bill 32, in 2006, which required the state to reduce statewide greenhouse gas emissions to 1990 levels by 2020. The state achieved that target 4 years ahead of schedule. California strengthened this commitment in 2016 with the passage of Senate Bill 32, which requires statewide GHG emissions to be reduced to 40% below 1990 levels by 2030. Recognizing the need to rapidly reduce emissions of the most potent climate-forcing gases, the state passed SB 1383 in 2016, which requires California to reduce statewide methane emissions to 40% below 2013 levels by 2030, as well as reducing organic waste disposal in landfills by 75% by 2025. Finally, AB 1279, passed in 2022, sets state goals to achieve carbon neutrality and reduce anthropogenic greenhouse gas emissions to at least 85% below 1990 levels by 2045. As implied by the name, the landfill methane regulation is targeted at reducing emissions of methane. So why is methane important? Methane is a potent greenhouse gas with a short atmospheric lifetime that scientists estimate is responsible for around 25% of the global warming that we're currently experiencing. Because of its outsized short-term effects, there's strong scientific consensus on the immediate need to reduce methane emissions to stabilize global warming in this decade. Improved control of methane emissions at landfills has also been found to reduce odor and a range of pollutants that are often present in landfill gas. According to CARB's greenhouse gas inventory, the waste sector is the second largest source of methane emissions in California, responsible for over 20% of the statewide total, as you can see here in the pie chart. Next, we zoom into landfill methane policies in California. As you may know, the Landfill Methane Regulation, or LMR, was one of the first regulations enacted in response to AB 32 in recognition of the opportunity to achieve immediate, cost-effective greenhouse gas emission reductions by controlling methane emissions from municipal solid waste landfills. The regulation requires owners and operators to install and optimally operate gas collection and control systems, monitor surface methane concentrations and other performance parameters, repair emission exceedances and other performance issues, source test, keep records of these actions and data, and report certain information to CARB. Following previous updates to federal landfill rules, in 2021, the US EPA issued a federal plan that requires California landfill operators to report certain information related to wellhead monitoring in addition to following the requirements of the LMR. The state has also established the intent to phase out landfilling of organic waste and is currently implementing regulations to reduce organic waste disposal in landfills pursuant to Senate Bill 1383. Statewide regulations requiring collection of organic waste became effective in 2022, and those efforts are ramping up to enable expansion of organics recycling infrastructure. The need for additional action to directly control methane emissions was evaluated in the 2022 Scoping Plan update. The Scoping Plan found that while reducing disposal is the most effective means of achieving long-term methane reductions, reducing emissions from waste already in place in landfills is also critical to achieve near-term reductions. Methane policies are built on research and technology, which has greatly improved in the past decade. We now have a better understanding of landfill methane emissions and effective reduction strategies. So with 14 years of experience implementing the LMR, we've identified some opportunities for improvement, considering new technologies, lessons learned, and the state's ambitious methane emission reduction goals that we discussed earlier. In the next 2 slides, we'll dive into some findings from research related to landfill methane emissions. Overall, research has shown that landfills are very complex systems, and a wide range of factors, including atmospheric, operational, biological, chemical, and physical conditions, may contribute to variability in the rates of organic waste degradation, methane generation, capture efficiency, and emissions. To better understand these factors and identify effective mitigation strategies, CARB has undertaken or supported a variety of research projects over the past decade regarding landfill methane emissions. These studies have employed a wide range of different technologies, as we show in this figure, which span geographical scales from individual landfills to statewide surveys, as well as a wide range of timescales from hours to months of monitoring. In December 2022, CARB hosted a workshop summarizing results from these research studies and the current state of landfill methane emissions science in California. The presentations provided perspective on the strengths and limitations of existing data and technologies employed thus far. For example, we learned that the locations and emission rates of leaks found by airborne methane surveys can change within the same day. This variability suggests that instantaneous emission rate data from remote sensing alone cannot inform us about emission inventories, as they provide only a snapshot of emissions at one point in time. However, important new tools have emerged for methane leak detection and repair, as we'll discuss in the next slide. Among the new capabilities, we see that remote sensing-based technology has unique advantages. Since 2016, CARB has sponsored multiple field campaigns using airplanes to demonstrate the detection capability of these technologies. In 3 campaigns from 2020 to 2023, CARB used the detection data to alert operators of plumes and ask them to look for the emission source and repair it. Those efforts demonstrated that aerial plume images can quickly pinpoint large leaks and provide valuable information to operators to find and fix them. An example of a plume image is shown here, and a link to a research report on those efforts is included in the slide. The findings of this work have helped inform the development of some of the targeted mitigation strategies represented in concepts throughout this presentation, both by demonstrating the detection and response capability and improving our understanding of the causes of large emission plumes. I hope those slides give you a good background about the policy framework and research regarding landfill methane emissions and mitigation. Before we dive into specific concepts, we want to provide an overview of the goals that have emerged from the policy framework, research efforts, and scoping plan analysis, as well as from our direct experience overseeing the regulation and the feedback we've received so far from all of you. The overarching goal of these potential updates is to improve methane emissions control to meet California's climate targets by leveraging technological advances and research. In addition to that, some other ideas we'll discuss today include changes to improve alignment with federal requirements, simplify reporting, to clarify requirements, and to update procedures and methods. In general, we think regulatory amendments are an opportunity to improve processes, streamline implementation, reflect new capabilities and data, and fix what isn't working well for regulated entities and regulatory bodies. Finally, as always, we're aware that other states and nations look to California as a leader in crafting their own climate strategies. So we want to make sure we're setting the highest standard for our GHG programs. We'll now talk through the anticipated timeline of this potential regulatory update. In May of last year, we held a workshop on potential updates to the LMR. In the time since, we've been further developing and refining concepts and continuing to engage with regulated entities, environmental groups, scientists and researchers, our regulatory partners at state, local, and federal levels, and other members of the public. Today's meeting is an opportunity for us to present a set of more detailed potential concepts for changes to the regulation, and to continue gathering ideas and feedback. We anticipate releasing a formal regulatory proposal roughly late next year. And in the meantime, we're committed to continuing engagement with stakeholders as we develop that formal regulatory package. Finally, based on this timeline, we anticipate implementing changes beginning in about 2027. Before we get into the details, we want to remind everyone that the concepts we're going to present today are preliminary ideas. Many of the concepts include detailed information. We included those details specifically to facilitate more meaningful feedback. We want to hear your thoughts so they can help inform the best possible regulatory proposal. So please speak up during this workshop or provide written feedback through our website linked on this slide. We're asking for written feedback by January 24th. We'll now cover a high-level overview of the preliminary concepts by topic. Most of these concepts will be covered in more detail later in the presentation. First, staff is considering a number of potential changes to improve monitoring requirements. We're considering requiring operators to perform on-the-ground leak monitoring and make repairs when alerted by CARB of a methane plume detected by a satellite. We're considering an application and approval process to allow alternative technologies to be used for surface emissions monitoring. We're considering several changes to surface and component leak monitoring procedures to increase the stringency and improve the frequency and coverage of that monitoring. Finally, we're considering adding requirements to monitor wellheads for temperature and air intrusion in line with federal rules. Staff is also considering several potential changes to improve the operation of gas collection and control systems, which we abbreviate as GCCS. We're considering changes to better limit the length of GCCS downtime and measures to minimize the emissions impact when downtime is unavoidable. We're considering requiring maintenance of a steady system vacuum for efficient and consistent landfill gas extraction. We're considering requiring additional monitoring, analysis, and mitigation measures in areas with persistent leaks or other recurring issues. And we're considering changes to the steps for managing declining gas generation at closed landfills, as they may encounter difficulties operating their gas collection and control systems. Finally, staff is considering several potential changes to clarify applicability of the regulation, improve reporting, and make other miscellaneous changes. We're considering clarifying the responsibilities of third-party gas control system operators that receive landfill gas, but don't own or operate the landfill. We're considering standardizing and streamlining the reporting format, including requiring digitized reporting, like digital maps of infrastructure and of emissions monitoring data. We're considering adding new reporting parameters that would help CARB to better oversee and confirm compliance with the regulation. And finally, we're generally considering minor miscellaneous changes, including clarifications of regulatory language, updated data, and adjustments to improve the enforceability of the regulation. Hopefully that broad overview helped orient everyone on the overall set of our current ideas for potential changes. Now we'll get into the details of many of the concepts we just introduced. For the remainder of the presentation, we really want to hear your feedback on the specifics of these concepts, and we'll be frequently pausing for live feedback. Throughout this portion of the presentation, we'll put up questions to help spark input, both live at this workshop and to consider later on for written feedback. That said, we want feedback on any and all aspects of these concepts, not just the questions that we've identified. So we'll start with concepts for potential changes to monitoring requirements. As we discussed earlier, airborne remote sensing technology has shown great potential for quickly identifying landfills with large methane emission sources and enabling timely mitigation. Airborne technologies aren't limited by landfill terrain or other safety issues, and can provide more comprehensive coverage than ground-based monitoring, though they only see larger leaks. Methane plume data from satellites will soon be available to CARB through two avenues. First, CARB has partnered with several entities in a public-private partnership, which launched one of two methane detecting satellites in August of this year. And second, CARB will separately purchase additional satellite data from a commercial vendor through a competitive solicitation process using a $100 million allocation from the state legislature. Links with more information on both of those efforts are included on the slide. Last year, amendments were adopted to CARB's oil and gas methane regulation that requires oil and gas operators to investigate and repair leaks detected in satellite imagery. Our concept here is to potentially adopt a similar provision for the landfill sector, where landfill operators would need to perform on-the-ground monitoring in response to satellite plume detection alerts sent by CARB. This would complement, not replace, the existing ground-based monitoring to quickly find and mitigate those largest emission sources that show up in satellite data. Similar to the oil and gas provision, in this concept, the satellite detection would indicate the need for follow-up monitoring by the operator. If the operator then discovers an exceedance of the methane standard, they would need to correct them, like other leaks found during routine monitoring. I'll now talk through the oil and gas provision as a jumping off point. Again, we're thinking of implementing something similar, so we want to hear your thoughts about how to make it work well for the landfill sector. In the oil and gas methane regulation, the executive officer needs to approve each satellite technology before they can be used for the provision. The technology has to have a resolution of at least 30 by 30 meters, deliver the data to CARB within 72 hours of collection, and produce an image of the plume. The technology also needs to demonstrate its methane plume detection capability. After being approved, CARB can notify oil and gas operators when methane plumes are detected by the instrument. CARB is required to send this notification within 7 business days of receiving the data to ensure that all actions are in response to recent plumes. The notifications include an emission ID for tracking purposes, the estimated location of the plume origin, the date and time of the detection, and the plume image. Under the oil and gas methane regulation, when an oil and gas operator receives a notification, they need to perform on-the-ground leak detection and repair in a 100-meter radius around the provided origin within 5 days. Some plumes in the oil and gas sector may be the result of allowable operational activities, like clearing gas from a pipeline before making repairs. If the operator has records to show those activities were occurring during the detection, they may report that activity instead. The operator then has to report the findings of the inspection within 72 hours of performing it. This reporting includes information like the date of the inspection, the type of emission source found, and an initial mitigation plan for how the leaks will be repaired. Upon finding any fugitive leaks, the operator is required to repair and remonitor those leaks within specific timeframes. Finally, the operator needs to report information about the repair within 5 days, such as the initial concentration and the repair date. This multi-step reporting process ensures effective oversight by keeping CARB informed of the operator's actions to find and fix the source. So now we'd like to hear your feedback. Seeing the oil and gas provision, does anything jump out that should be different for the landfill sector? Please raise your hand in Zoom if you'd like to ask a question or give feedback, and we'll call on you and allow you to unmute.
Hello, Quinn. We have Craig Cecil. Cecil, I'm going to unmute you. You could go ahead with your question.
Hi, this is Craig Cecil with Butte County. I oversee the landfill here, and one thing that I think is different with these provisions is that a oil and gas industry is privately owned. I don't think you're taking into consideration municipality ownership of landfills. Things do not, the available income resources are not available at the same level. And the process we have to go through to get things approved is not the same as a for-profit agency. So those are some things that I think would be valuable to keep in mind. That maybe if you're a for-profit agency, this works great, but if you're a municipality, again, I have to go through a board of supervisors for allocation of resources. It takes time. The board meetings aren't every week. They're sometimes a month. And if I don't get the board agenda item in time, we could be delayed 2 months before I can even get an item approved to start the process. So just hope you keep that in mind when with making your decision. And thank you. And if I can, earlier there was a gentleman on that made a comment in the pre-lunch meeting that I raised my hand and didn't get the chance to speak. Something with that technology that I don't think was considered when discussing his issue with a landfill in his area that was emitting emissions, that putting that electronic technology on there, if he's still on listening, putting that electronic technology, that I forget what the name of the technology is, but one that's creating more long-term waste, e-waste, batteries, solar panels, all that stuff that is carbon-based. And then also just putting that technology on is not going to necessarily fix an emission issue. It could be an issue with not enough landfill gas collection system. And then also, again, the resources, who's going to pay for that? As all the speakers that were great speakers on, they all are on active landfills that can raise the cost of their services to compensate for those fees. Where if it's a closed landfill, the surrounding neighbors through their property taxes or something are going to go up to cover those fees. So just something to keep in mind in that service when that wasn't discussed earlier. So again, thank you for letting me speak, and great presentation.
Thanks so much, Craig.
Thanks, Craig. Next up, we have Nick Lapis. Nick, I'm unmuting you. Go ahead and announce yourself and begin with your question or comment.
Hi, this is Nick Lapis with Californians Against Waste. Trying to see if I can turn on my video, but I don't think I can. I have a comment on this specifically, but also on the voluntary use of the advanced technologies. Should I save that second comment for further down the presentation, or should I make it now?
No, that would be good to save that comment. Thanks, Nick.
So on this specifically, I think it's a good framework as a starting point. I think this is along the lines of what we've been referring to as a super emitter response program. There are two things that come to mind, though, as potentially concerning. One is just the long time frame between finding a leak and notifying the landfill operator. It seems like that can be done a lot faster. But more importantly, I worry about the ongoing financial sustainability of relying on general fund funded satellites. And I think you should consider looking at a polluter pays model for implementing this program, with maybe assessing landfill operators a proportional fee of the cost of operating the satellites. Thank you.
Thank you, Nick. Next up, we have Frank Capone. Frank, I'm going to unmute you and go ahead with your question.
Good afternoon. Frank Capone. I'm retired from Los Angeles County Sanitation Districts. I'm currently an officer with the SWAN Legislative Task Force. A lot of the presentation so far, and you may be addressing this later on, the reporting and the mitigation measures are all reported to CARB and CARB staff. I'm hoping that there will be a ability to delegate this to the local air districts. They're far more capable of handling this type of thing. And to Nick's point about timing and getting mitigation done after a leak is reported, once again, they're better equipped to be able to handle this in a shorter time frame. So I'm hoping that's going to be available to be able to, once you get the regulations all set in place, to be able to delegate that to the local air district, just like you did with the original LMR. Thank you.
Thank you, Frank. I'll just chime in there to say that, we are coordinating with local air districts on this. So, definitely going to have some good conversations and make sure that, we all collectively have the resources that are needed to add this if the concept moves forward. I also wanted to mention, I think both you and Nick brought up the issue of the potential time lag between, when a plume is observed and when an operator might receive the notification about that. I think that's one of those things we can absolutely expect to improve over time with the airborne flights that we mentioned, and we'll talk more about later. I think they were able to get the average notification time down to 4 days on average, meaning some, were much sooner and a few took a little bit longer. And I think, as Quinn showed on the slide, there's a minimum set for the oil and gas regulation that technology has to be able to get that notification to us within 7 days. And we've been working really hard to get ready for that and make sure that we're not creating bottlenecks and are able to get that information flowing really quickly, because I agree that's really important.
Yeah, just to clarify, the information has to come to us within 3 days in the oil and gas regulation, and then we have 7 days on our end to send out the notification, and that's time to verify that the plume is a real plume, to do the quality control checks and to get that operator information sent out. So yeah, those are maximums. So as Antti mentioned, the goal is always to get things sent more quickly than that.
Thanks, everyone. Quinn, we don't have any raised hands at the moment.
Okay, thanks. Then I will move on. So moving on now to talk about other types of remote or near ground sensing technologies that operators can use to supplement monitoring efforts. Next generation monitoring technologies like aerial surveys using drones and aircraft or other autonomous vehicles, handheld technologies like laser-based instruments, and continuous emissions monitoring technology like mounted cameras or sensors. These all offer significant advantages over traditional monitoring methods. Several of these technologies are commercially available, and new ones are emerging from research and development. Next generation technologies can enable increased coverage of the landfill surface, greater monitoring frequency due to lower labor intensity, increased safety for monitoring personnel, and improved consistency. US EPA has mechanisms to broadly approve alternative monitoring instruments or procedures for various federal rules. So for example, US EPA approved the use of a drone-based monitoring technology in a method called OTM 51. US EPA also has a more specific alternative monitoring approval process for oil and gas facilities, and we have that process linked on this slide as well. However, the LMR has no similar mechanism to approve an alternative monitoring instrument or procedure to be available to all landfills. Under the current regulation, operators may only request an alternative on an individual landfill basis. Regulatory provisions allowing widespread use of alternative technologies under the LMR could lead to greater uptake by the industry, promoting a more proactive, comprehensive, and efficient approach to methane emissions management. Several stakeholders submitted feedback in support of changes that would encourage adoption of advanced monitoring alternatives. Several stakeholders suggested that alternative technologies should be required to increase frequency and coverage over the existing LMR surface emission monitoring procedure. Many operators have expressed interest in adopting new technologies, and many have tested remote sensing as a screening tool to supplement on-the-ground monitoring. Overall, the feedback conveyed broad agreement that staff should develop a process to evaluate new monitoring technologies as they become available and as their capabilities are demonstrated. In light of the potential advantages highlighted and the feedback received, we're considering establishing a process within the LMR for CARB to evaluate and approve the use of next-generation technologies to perform initial surface emissions screening. Under this concept, technology providers would need to submit an application to CARB, demonstrating that the proposed alternative method is no less stringent than LMR's surface emissions monitoring, or SEM, requirements, and is able to cover the entire landfill, including areas that may be considered inaccessible or dangerous. We envision that the procedures for an alternative monitoring approach would use the remote detection as screening to identify areas that are potentially in exceedance of the methane standard. Then the location would be monitored with ground-based SEM to confirm whether there is an exceedance, the maximum concentration, and the total affected area. Approved technologies would be listed on CARB's website. We believe that adding a process for broadly approved alternatives in the LMR could accelerate adoption of next-generation technologies. A robust evaluation process is important to ensure that each instrument's capabilities and limitations are understood, and we anticipate that a specific procedure tailored to the technology may be needed for each alternative. All right, so now I'd like to hear your feedback on this area. How do you envision this process should work, both for the application and for CARB's evaluation? Go ahead and raise your hand in Zoom if you'd like to speak.
Okay, we have Nick Lapis again. Nick, I'm going to unmute you.
Hi, good afternoon again. Nick Lapis with Californians Against Waste. I have to say, it is pretty disheartening to see that you are still referring to the voluntary use of these technologies. I mean, we spent the entire morning hearing about the technologies, both in the ways that they make up for the lack of the existing system and the way they are already being used by the landfill operators. The current SEM system doesn't work. And the last speaker before lunch really made it clear that it's unreliable. The pattern is too far spread, etc. There are whole parts of the landfill that we can't cover with SEM, including the working face and steep slopes. And the idea that we would allow somebody to just replace a human walking on the landfill with a drone and not address all those other requirements and not make it mandatory is just an incredibly blown opportunity. So we would strongly encourage you to mandate the use of these technologies. I think you should look at a model similar to what Waste Management presented earlier in the morning, where they basically described 3 tiers of monitoring. They said they do ongoing stationary monitoring, and then they have monthly monitoring, which they suggested that monthly could be satellites, although I think satellites could also be ongoing as well. And then they had quarterly, where they had SEM and they had drones, but realistically, there's no reason that a drone could only be used once a quarter. The reason we do once a quarter now is because of the physical limitations of people having to walk on the landfill. But there's absolutely no reason why a drone couldn't cover the landfill once a week. And finding a methane leak earlier is a very important part of reducing these emissions, because a pound of methane today is not the same as a pound of methane in 6 months. So again, we encourage you to go far beyond what you're proposing here, make it mandatory, expand the scope, and really don't blow this opportunity.
Thanks, Nick. Quinn, we have a few raised hands. Next up in order of the raised hand is John Borrego. John, go ahead.
Hi, John Borrego with the Yolo County Central Landfill. So we have been doing this now since the beginning. And we've done a number of evaluations of more remote sensing things. The challenge in my mind, so if there is an alternative remote sensing thing, would that, and it only makes sense to me to do it if it actually replaces the sort of standard quarterly or annual walking the landfill thing, and then you do the walking portion or the on the ground portion when you find something using this remote sensing, a remote sensing alternative. I don't think requiring a specific alternative is a good approach. I do think that making alternative approaches easier to get approved and into the system is absolutely the way to go. Thank you.
John, next in order, we have Frank Capone. Frank, I'm going to meet you. Go ahead and introduce yourself and start with the question.
Hi, Frank Capone again with the SWANA Legislative Task Force. I just wanted to disagree. I wouldn't be doing my job if I didn't disagree at least once with Nick on this concept of mandatory remote sensing alternative technologies. Your own data shows that the vast majority of landfills have been shown to be below 200 parts per million. I'm sorry for the background noise. Today's garbage day here. And more often than not is that the remote sensing satellite programs, as well as the aircraft flyovers, what they demonstrated quite convincingly is that the vast majority of landfills were well within their limits and almost undetectable in almost every situation. Yes, there was a bunch of standouts, but those were still only few and far in between. So I think in terms of cost effectiveness, and someone had brought up earlier, the fact that you're dealing with municipal landfills, budget is an issue. These programs are already these landfills are already heavily invested in their monitoring programs. And once again, as the data is showing, they're doing a good job, that it really is not much bang for your buck to be able to make this mandatory and require very expensive technologies to be implemented or made to be implemented by a large number of these landfills that are already in compliance. And so, I think you need to recognize that the vast majority of the people are doing a really good job, and this would be punitive. Thank you.
Thank you, Frank. Next up, we have Catherine Blavel. Catherine, I'm going to unmute you, and oh, you dropped off. Catherine, once. Okay, next up, we have Jennifer Elkins. Jennifer, I'm going to go ahead and unmute you.
Hi, I'm Jennifer Elkins. I'm a resident of Valverde, and I am heavily impacted by a landfill that's very close to my community. I have to agree with the gentleman earlier that these drones and fixed sensors, they need to be a requirement. They need to be mandated. It should not be something that we're just thinking of. This should have happened. I mean, it's long overdue. Yeah, when the methane emissions, go above exceedances, and you got VOCs and air pollutants. My community, I have 10 neighbors with cancer on my block alone, and we fully believe it's from this landfill. There's kids that are having issues with breathing and their skin and bloody noses that go to school nearby, and so I think it's really important that we're monitoring frequently and more effectively. So yeah, I definitely agree that the drones and the fixed sensors, they need to be mandated. It needs to be required.
Thank you, Jennifer. Next up in the queue is Christopher Chavez. Christopher, I'm going to unmute you and you could go ahead.
Yes, good afternoon. This is Chris Chavez with Coalition for Clean Air. Just want to agree with the comments that this monitoring technology should be mandatory rather than optional. These available technologies are going to make it much easier and much quicker to detect such leaks. And I think the other important aspect is that finding and fixing leaks is also going to reduce not just emissions of methane, but also chemicals like benzene that are harming residents. And we know from experience with a number of different communities that are near landfills, such as Chiquita Canyon, that we need to really, reduce those health harming emissions, not just our greenhouse gas emissions as well. As we know, air pollution air quality is a big concern, particularly in Southern California, which is an extreme non-attainment of national air quality standards. So we need to make sure we're reducing every pollutant we can. Thank you.
Thanks, Christopher. It looks like Catherine Blauvelt is back. Catherine, I'm going to go ahead and unmute you.
Thank you. Catherine Blauvelt, Circular Economy Director for Industrious Labs. Really thankful that this webinar is happening, and we're at this point talking about technologies. Just want to underscore, I'm looking for sort of the reasoning, the rationale to make more effective monitoring technologies sort of extra credit as I see this schema. And again, we've heard pretty clear information and seen quite a lot of studies now that have underlined we're just missing a whole lot of methane emissions, and that is really game over when it comes to this regulation's effectiveness in achieving its stated goal. So hope that the CARB staff can really look at requiring comprehensive monitoring. As we saw, walking STEM simply does not get to the methane leaks unless you stumble across them. It's a little bit like firefighters looking for the fire. Fire is down the street and they are wandering around hoping to run across it. There is simply better technology out there, and it really is quite an opportunity to ensure that, again, we actually have emissions mitigated, and the stakes could not be higher as it's a carrier gas. And there are real human impacts when you don't mitigate methane. So really appreciate at this early stage you folks looking at requiring better technologies than walking SEM.
Okay, thank you, Catherine. Next up, we have Veronica Aguirre. Veronica, I'm going to meet you and go ahead with your question or comment.
Hello, good afternoon. My name is Veronica Aguirre. I'm with Central California Environmental Justice Network. I also am a resident of Avenel, California, who we also have a landfill, Avenel landfill, right in our community. I just wanted to kind of piggyback off of what Nick and others have mentioned about the importance of making it mandated to have this technology rather than voluntary, because voluntary basically is non-existent. We already know when you put voluntary on there, many people are going to, like the one gentleman had said, it's going to be costly, and rather than caring about people's health, they're going to watch the bottom line. And I feel that making it mandated is going to be what is good, as especially being a good neighbor. We know when you have polluters like landfills right next to community schools, health, homes and health clinics, it makes it very important to that we are making responsible decisions. And I really think that it's very important that we make technology like this mandated rather than voluntary. And as Mr. Risk had mentioned and highlighted, he said that the need for more comprehensive monitoring and that the walking sim is an effectiveness in the walking sim. So I really think that somebody, a professional like that already is in the industry is mentioning something like this. It's a good indication that, technology definitely needs to be mandated rather than voluntary. So thank you very much.
Thank you, Veronica. And next up, we have Craig Cecil again. Cecil, go ahead. Or Craig, go ahead.
Thanks again, Craig Cecil, Butte County. Something that has been overlooked in this conversation, and Frank touched on a number of really good points. Something that's been overlooked, though, is SB 1383, the mandatory removal of organics from landfilling. So as that happens, methane, as we have been told by all you experts, is going to drop off basically, which would negate the necessary need for this mandatory additional monitoring. Closed landfills maybe that have been around for a long time, maybe it's something to implement. I think it should be on a need basis, but as we are removing organics from landfilling, methane should be non-existent nearly, and this additional monitoring financial burden will be negated with that removal. Thank you.
Okay, thank you, Craig. At the moment, we do not have any raised hands. And it looks like Catherine, you raised your hand again. I'm going to go ahead and unmute you.
Thanks. Absolutely recognize that, look, we need a monitoring schema that's layered and responsive to landfill surface. I will note our organization conducted a modeling an analysis on exactly what the last speaker spoke of, organics diversion and mitigating landfill methane. And unfortunately, there is so much tonnage of so much organic waste in landfills today. It will take many, many years to see substantial methane reductions, even if you tomorrow had zero organic waste entering into landfill today. So it is absolutely the best and most effective long-term strategy, but the most effective short-term strategy, and by that I mean several decades at least, unfortunately, is dealing with the organic waste we are stuck with across the state.
Thank you, Catherine. Next up, we have Kurt Fuji. Go ahead and start with your question. I'm going to unmute you.
Thank you. Can you hear me? Am I unmuted?
We can hear you fine.
I just want to emphasize or remind or support the statement from the morning that one size fits all is not a really good, effective approach. If CARB ends up requiring or encouraging newer technologies, please bear in mind that landfills are very individual and distinctive, and a very restrictive, prescriptive requirement will not accomplish your objectives, or it's not the best way to go about things. And I would mention that the the Title 27 provisions for alternatives to the prescriptive liner requirements are probably a good example. I know that alternatives are frequently proposed, reviewed, and either approved or rejected by the water boards. And I think that's a good model to follow in allowing competent professionals to address site-specific differences. Thank you.
Thank you, Kurt. Next up is Karen Kanzanjiad, and excuse the pronunciation of your last name, Karen, or Garen, excuse me. Go ahead. I'm going to unmute you.
Hi there. Garen Kazanjian with Recology. I just wanted to echo the comments of the last speaker. It seems like with this process that CARB is going to undertake to have different types of technologies, and with the kind of varying technologies that are available right now, it seems that maybe some patchwork, or some satisfaction of a standard by having various site-specific standards that they're doing, or practices that they're doing there to allow to achieve the standards, I think makes sense, because you're absolutely right. Landfills are different, and requiring one size fits all is going to be it's just going to make it more challenging. And so the ability for any given landfill to say we've done X, Y, and Z, and maybe it's not every single one of those practices, but it is a sufficient combination to prove to CARB that we're undergoing regular monitoring and we're meeting our burdens, I think would make sense.
Thank you, Garen. And next up, we have Jennifer Elkins again. Jennifer, I'm going to unmute you.
Hi, thank you. I just wanted to add that impact some landfills financially, and it's probably a big cost up front. But overall, this is going to protect the environment and the communities that live near these landfills, because when these methane emissions go undetected, the communities really suffer. And we're seeing that over and over again across the country, all these different communities and neighborhoods being impacted, and their health being impacted, and their quality of life being impacted. And so I think it's a really small ask for this requirement to be mandated to protect not only the environment, but the people living near these landfills. And that's kind of a duty that you guys hold to do that.
Okay, thank you, Jennifer. Next up, we have Eleanor Garland. Eleanor, go ahead.
Thanks. This is Ellie Garland with RMI. I just wanted to reiterate some of the points that others have made on leveraging drones, fixed sensors, fence line monitors, and other readily available technology for the routine monitoring of methane emissions. I agree these technologies should be mandatory, since they are cost effective. They tend to be cheaper than walking, and can cover more of the landfill more often and objectively, while keeping workers and communities safe. And I think this is especially important for the working face emissions, since they do contribute disproportionately to the total. Thank you.
All righty. Thanks, everybody, for all that feedback. I'm going to move on to the next topic now. And of course, we'll have another session at the end for open discussion. So the LMR allows the working face of the landfill and certain areas with construction activity to be excluded from surface monitoring. Additionally, alternative walking patterns can be approved to avoid potentially unsafe areas like steep or slippery slopes. These exemptions are broad and lack specific measures to limit the impact of missed monitoring events. As we showed in our last workshop, and we'll cover again later today, a large fraction of the methane plumes detected in airborne remote sensing were from the working face or construction areas. US EPA has observed operators excluding more areas from surface emissions monitoring than should be allowed under their regulations. And CARB has also observed that some operators omit required monitoring, such as at cover penetrations where compliance inspections frequently find leaks. Staff is considering several clarifications or changes in this area. First, we want to make sure it's clear that although alternative walking paths may be used for integrated monitoring, the regulation still requires monitoring of cover penetrations, including gas extraction wells, cover cracks and other areas with signs of potential leaks. It's important to monitor these areas for potential emissions, departing from the standard walking path as often as needed. Second, we're considering specifying that an area of the landfill surface can be excluded only where and while activities are being conducted that make it unsafe to monitor. For any area initially excluded, monitoring should be performed on another day within the same quarter. Where it's not possible to conduct monitoring in a given area for a full calendar quarter, we're considering requiring a remote sensing method be used to screen the area, such as a handheld or drone-mounted tunable diode laser. We've received public feedback advocating the use of drones and other alternative technologies to monitor areas currently excluded from surface emissions monitoring due to safety concerns. Having observed that some of the most leak-prone areas are frequently being omitted from monitoring, we agree that it's important to ensure these areas are monitored. And with that, we'd like to hear your feedback on our concept to reduce SEM exclusions. Please raise your hand if you'd like to provide input.
Okay, Nick Lapis, you are first up. I'm going to raise your hand.
Hello again, Nick Lapis with Californians Against Waste. Just wanted to say that I appreciate that you guys are including this. It's a glaring omission from the original LMR that we're not looking at the working face and the steep slopes, and they should definitely be covered. Thank you.
Thanks, Nick. We do not have any raised hands at the moment, and Catherine Blauvelt is back. Catherine, go ahead.
Thanks for pronouncing my name right. Catherine with Industrious Labs. This is really exciting because of the research, as you folks have noted previously, that has, it's co-authored by the EPA. There's scientific studies out that quite a lot of emissions are coming from the working face. And then we have, in addition to that, even more areas that are simply not being monitored at all. So my question or suggestion is to certainly for the working face, just establish a schema approach such as the EPA white paper suggests, right? Fixed sensors, and that's just simply the way that you're able to then monitor and have appropriate protocols in place for that particular area. So just really encourage that to be robust and really take a great step forward.
Thank you, Catherine. And we'll just wait for the next raised hand. We currently do not have any questions on our LMR email. John Borrego, your hand is raised. I'm going to unmute you.
Hi, just a quick comment on the exclusion area stuff. I do think that this is an area where I lost my train of thought. It is important to find a way to include these areas, especially active face areas or areas where you've got a lot of other activity going on, such that it's difficult to monitor by walking through it with a handheld detector. I would be a little bit cautious about specifying what exactly the detector needs to be for that. And maybe that's, and this is where we get back into something somebody brought up a while ago of making sure that the local air districts who pick up enforcing this, who then have the staff who can work with the operators and landfills that are doing it to say, okay, for your site here, you could, and the way your active face is monitoring, you can set up, a couple of, remote standard, on a tripod sensors, and that will be adequate. And then other people, well, you really should, the way yours is set up, you really should do some sort of flyover thing and and all of that. I do think that I would be cautious of specifying exactly, but having some sort of scanning of these areas is important. Thanks.
Thank you, John. Next up, we have Christian Koline. Christian, go ahead. And Christian, you should see an unmute button. If you could unmute yourself.
Okay, I think we'll move on now. There's always the open discussion at the end, and we have a comment docket. So if there's any more thoughts, we'll have more opportunities to have those expressed to us. So moving on to the next topic. As we discussed in our prior workshop, when LMR was initially developed in 2009, staff proposed an instantaneous surface methane standard of 200 parts per million by volume, or ppmv. In response to stakeholder concerns, the current regulation set a 500 ppmv standard and required reporting only for leaks from 200 to 499 ppmv. Staff analyzed reported instantaneous SEM results from 2016 to 2020 to investigate the feasibility of a lower standard. The figure here shows the results of the analysis for 2020. The vertical axis shows the total number of SEM readings reported by all landfills in California that are subject to the LMR. The horizontal axis shows the results from the initial monitoring event and for each subsequent remonitoring event after corrective actions had been taken. SEM readings are color-coded based on their concentration range. The analysis shows that landfills are largely already operating below the 200 ppmv threshold, and that most exceedances were corrected to below 200 ppmv in the initial corrective action, so that first remonitoring. As a result, staff's concept is to potentially lower the instantaneous standard to 200 ppmv. This same data was presented at the May 2023 workshop, and after that, we received feedback on the idea. Operators suggested that mitigating these smaller leaks would likely not result in a meaningful amount of emission reductions. Some commenters also reiterated the concerns brought up during the adoption of the original regulation, that adhering to a more stringent standard could lead to increased air intrusion, increasing the risk of subsurface fires, and presenting challenges for landfill gas to energy projects. But other commenters agreed that the data show a reduced limit is feasible, and that there's no evidence to suggest increased risk of landfill fires at this lower threshold. So in consideration of those comments we received, we'd like to solicit more specific feedback, and we have some questions on this slide that we hope will help with that. So please raise your hand now if you'd like to speak, or again, there'll also be a written comment docket that you can submit comments to later if you'd prefer to do that. So go ahead and please raise your hand if you'd like, to speak.
Thanks, Quinn. We're just waiting for some hands. Okay, Nick, you're up again. I'm going to unmute you. Just unmute yourself and go ahead.
Hi, Nick Lapis again with Californians Against Waste, and I apologize for speaking so much. Just wanted to echo staff's interpretation of the 200 part per million requirement, and that it's not likely to cause any issues. This was originally proposed in the 2007 early action measure that was adopted in 2010. And at the time, there was pushback on lowering it from 500 to 200. And the compromise that was reached was that we would require reporting of exceedances between 200 and 500, but have the standard be at 500. And that based on that data, we would then come back and see if it made sense to reduce the requirement to 200, or if there could be a risk of air intrusion or anything along those lines. And I think it's pretty clear from the data you did get that that isn't a concern. So it's definitely appropriate to reduce it to 200. Thank you.
Thanks, Nick. Next up, we have Tyler Holleby. Tyler, I'm going to unmute you. Go ahead and unmute yourself and start with your question or comment.
Hello, Tyler Holleby with US EPA. I regularly conduct inspections at landfills, and I find that the majority of the surface emissions monitoring exceedances that I find are at cover penetrations, and where the operator has cited, the reason for low vacuum at those cover penetrations is due to air intrusion. We find that we additionally have concerns with the cover integrity near that cover penetration point. So where you have poor cover integrity and high cover porosity, we find that you get air intrusion when you have slightly above optimal vacuum, and you get surface emission exceedances above 500 when you have slightly below optimal vacuum. So I'm not sure if this is one of your proposed changes maybe later in the presentation about cover integrity improvements, especially around cover penetrations, in order to address some of these operators' concerns with the lower limits. Or otherwise, but I would highly suggest that if not.
Thank you, Taylor. Next up, we have Frank Caponi again. Frank, I'm going to meet you. Go ahead and meet yourself and start with a question.
Thank you. Just a point on the original LMR that had 500 ppm, and I know there was an argument back then to lower it to 200 at the time. The quid pro quo at the time, the other shoe here, is that the integrated standard, was originally proposed at 50 ppm, consistent with other air districts like the South Coast AQMD's 1150.1, and it was agreed to lower that to 25 ppm. Bear in mind, and this kind of goes back to some of the original comments, and I understand some of the residents around landfills express concerns, and as I originally pointed out, there are some bad actors out there, and those should be addressed, I think, very severely, because the rest of the industry is really doing a good job. So they're kind of giving the industry a bad name, I think. And I fully agree that there should be a level of hybrid between the remote and the surface monitoring. But also bear in mind, we keep talking about the instantaneous, which would look for leaks. But the integrated is a measure of how well your gas system is working. And we did lower that standard to 25. And you're not presenting data on that, but I think the vast majority of landfills are well in compliance with that, demonstrating that their gas systems are working well. And I know a lot of residents that don't live this stuff day in and day out and may have some legitimate concerns about a poor neighbor in the landfill that's by them. That is an indication that the landfill is working well. I know the gentleman from EPA was talking about some penetrations being leaks, and yeah, that certainly is an issue. But bear also in mind that these are minor leaks, and so they would not contribute substantially to methane emissions from a landfill. If ARB is thinking about lowering that standard, I think, bear in mind that there already was a quid pro quo in this, and we already agreed to lower one of the standards, and that standard was talking about how well your gas system's doing. And just one other comment, I know I'm going on here. Someone had spoken earlier about how, if you do drones and you don't have to spend the money for people walking the landfill, don't forget that drones are not to take the place of folks that are walking the landfill doing monitoring. They have to work hand in hand. All the drones are doing is pinpointing areas where there may be concerns, and it always has to be followed up by someone walking the landfill. So, bear in mind that the drones are not the be all and end all of monitoring. You still need human monitoring to be able to substantiate where the areas are specifically that are of concern and the possible fixes that need to be implemented in those areas. Thank you.
All right, thanks for those comments. We're going to move on to the next topic now. So, talk about SEM corrective actions and remonitoring timelines. Under the current regulation, after finding a SEM exceedance, corrective actions and remonitoring must be performed within 10 days. The same timeline applies for further corrective actions if there's an exceedance in the first remonitoring. In response to feedback from our last workshop, we're considering reducing the timeline to initiate corrective action to 3 days, because mitigation usually involves simple actions like adjusting well vacuum and performing cover maintenance. But we're also considering retaining the current 10-day timeline for remonitoring to address concerns that were brought up at our last workshop about challenges in scheduling monitoring on a faster timeline. Things like weather issues and staff availability. If surface emissions are not corrected below the standard by the second remonitoring, a new or replacement well has to be installed. Currently, regulators are not informed of this until the next annual report after the construction is complete. We're considering requiring the operator to notify the agency within 30 days of identifying the need to install a new or replacement well. This would support effective oversight to confirm that mitigation measures are in place during construction, that an updated design plan is submitted, and that the site returns to compliance within the allowable timeline. This notification could also allow the operator to propose an alternative corrective action plan in writing. Under the current regulation, once an exceedance is corrected below the leak standard in either the first or second remonitoring, no further monitoring is required. But we've observed many cases where a leak reappears shortly after being fixed, indicating that the corrective action wasn't durable. We're considering adding a further confirmation remonitoring 1 month after the initial exceedance, in line with the US EPA's emission guidelines. Under the concept, a new or replacement well would need to be installed if that 1 month remonitoring shows that the exceedance has not been corrected. Finally, we're considering changing the onset date for the 120-day repair period from the date of the third exceedance to the date of the initial exceedance. That change would align with US EPA's emission guidelines and would ensure corrective actions are taken more promptly. So now we'll pause again for feedback on these potential changes. Please feel free to raise your hand in Zoom if you have comments or questions.
Thank you, Quinn. We have Michael Caprio. Michael, I'm going to go ahead and unmute yourself and begin with your question or comment.
Okay, just a thought. Thank you for putting the workshop on, by the way, very, very helpful. The slide that spoke of the concept in response to feedback received in May of 23 workshop, staff is considering requiring corrective actions to be initiated within 3 days, but the current rule is corrective action and remonitoring. So I guess the question is initiation. Once you start a repair, does that constitute compliance with that standard versus what is in today is completing corrective action and remonitoring by that 10 days? Those are two different things to me.
Thanks, Michael. You're absolutely right. That's how we're thinking of that, is that you need to start taking that action promptly, and that this idea is really informed by what we've seen in so many reports, that those initial corrective actions that you can try out first are often completed on the same day, right? They're simple fixes, and so we just want to make sure that folks are starting to the process of identifying the issue and remediating it as soon as possible. So, shortening that time period to within 3 days. And then I think, something that really supports and underpins that is this shortening of the 120-day timeline, right? It's still 120 days, but it starts from that first initial exceedance. So that gives you an incentive to, exhaust your easy options for fixing it, right? So that you're giving yourself more time to plan and complete the instruction and installation of a new well if that's what's required to remediate that leak. So I hope that answers the question.
Yeah, we can get more into it when the regs are put out and talk through it, but that helps with my view of it. Thank you.
Thank you, everyone. Next, we have John Borrego again. John, I'm going to unmute you. Unmute yourself and start your question.
Hi, just a quick comment on the first question about 30 days sufficient period for and what should be included in construction notification. I actually really like this sort of a provision. Very often in our case, putting in a new well isn't actually the proper corrective action when we have a longer term exceedance. It's either a large scale cover correction or rearranging how the existing gas wells are done or reconditioning an existing gas well, something like that. And being able to provide a notice saying what we're going to do is this entire acre needs to have its cover fixed to fix this problem is different. And since we're a municipal agency, it's much easier for us to do that than to contract with a driller to come and, as somebody else alluded to earlier, that, as a municipal agency, getting the authority to spend money on stuff like that sometimes takes a time, and getting something through our board of supervisors for, public notice for contracts, bids and all of that can easily take 120 days just to get a contract with somebody in front of our board of supervisors versus getting the work done and then remonitored. So I do think that this sort of a notification and adjusting the language of what that sort of corrective action should be, instead of it saying has to be a new well, but propose something for CARB or your local air district who are reviewing this to agree with, I think is the way to go. Thank you.
Thanks, John.
Okay, we'll go ahead and move to the next topic. So the LMR requires surface emissions monitoring to be performed using a walking pattern with 25-foot spacing. This means the space between those walking paths is not directly monitored. For instantaneous surface monitoring, some operators employ a best practice of searching the area surrounding each exceedance to determine the full area with elevated methane concentration, and then remediating that entire area. For integrated surface monitoring, records have shown exceedances detected in one monitoring grid appear to shift to a neighboring grid after corrective actions and remonitoring has been performed on that original grid. We're considering updating the instantaneous SEM procedure to require monitoring around each detected exceedance to determine its full area. The initial concept is to use concentric circles with a tight spacing interval, and then to continue monitoring until no location on the circle exceeds some concentration threshold. The full area with a maximum concentration above that threshold would then need to be remonitored after corrective actions were taken to ensure full remediation of the leak. For integrated monitoring, staff is considering expanding the remonitoring area to include all adjacent grids, as shown in this diagram. This would ensure that the corrective actions fully remediate the issue rather than diverting the methane elsewhere. Okay, so we'd like to hear your feedback on these concepts for determining the full extent of instantaneous and integrated surface leaks. Go ahead and raise your hand now if you have questions or comments.
I'd love to hear any input here from operators who have used this practice. I know we've heard from some that that do this kind of tighter spacing around any exceedance that they find. And I believe I've heard folks tend to use like a 1 meter or 5 feet type of spacing. So, you know, much tighter in order to, you know, make sure we're identifying that full area. So we'd love to get some really specific thoughts on what's been shown to be effective with that practice. Also want to be able to, you know, make sure that our the procedures are clear in the eventual, you know, regulation. And so if the concentric circle pattern doesn't make sense, that's another area that we're interested in hearing from you folks on, for example.
Thank you, Quinn and Althea. We have a question from Craig Cecil again. Craig, I'm unmuting you. Unmute yourself and go ahead.
Hi, Craig Cecil, Butte County again. So with the, I'm not sure the instantaneous needs to be changed to concentric circles, because when you're finding an instantaneous hit, it's in, you're finding the location. It's either a crack, a penetration, well bore seal, well casing. You're finding the direct location of that instantaneous, thus the term instantaneous. Integrated, where you're going around and walking a serpentine path through a grid, you're not necessarily looking for, well, you're looking for these cracks and penetrations that you're ultimately going to check at some point or already checked. So to find a concentric circle around something you already found, it seems like a waste of time to me, because you're kind of checking that area when you're doing an instantaneous anyway. If you are going along and your TVA starts beeping or says you're finding an elevated location, you're checking that area for what's finding it. So to do concentric circles just to make yourself dizzy is not increasing anything that you're doing already, because you're going to flag the area you found a exceedance at, a crack or a wellbore seal or a penetration already. It seems like you're adding additional what seems to me is that the people creating these rules have never gone out and done this sampling before, and that you have no idea what you're really doing other than just drawing circles around an area and thinking it's going to fix something, when the person doing the sampling is already finding that instantaneous location. So that's my point to what you're trying to do here. And when we do integrated sampling and have a grid that's has an exceedance, if they go back and check that, you're already found that that area is the location that's hot. If you go back 10 days later, which is the requirement now to do follow-up monitoring, which is also the one for instantaneous exceedances, you go back for a 10-day remonitoring. If that grid, prior your initial, you're checking all the grids around that. So you're already knowing the location of where your exceedance is at. To go back and check additional grids, you're just creating an additional financial burden on landfills that's not necessary. Again, seems like the people designing this have never gone out and done this sampling to know that that is not needed. So that's where it keeps seeming to me that the regulators, I could ask every single one of you, how much sampling have any of you done personally in this type of field? And most of you are desk jockeys and probably have never walked on a landfill. Some of you have never even been to a landfill to see this in the first place, is what I get when CalRecycle staff comes out to my landfill. So it's a little disheartening that you keep making rules without going and doing the sampling yourself to see what is going on by these professionals, that they do this in a very well manner. And like right now, I'm in an expansion to expand a gas collection system in a grid. And so it's already being done very well. And to go from 500 ppm down to 200 ppm and lower it there, I mean, you're dropping it down to 0.02%. That's such a minuscule amount of methane that is not, in my opinion, what's affecting these people that are being affected at landfills around. You're talking more of higher percentages. You'd probably have a 1,500 to 3,000% or ppm being emitted from a source that's affecting the people in the neighboring blocks or whatever houses. It's not 200 ppm is not affecting those people. So to me, it just seems a little uh, minuscule what you're going after right here to make the costs go up substantially. So thanks for allowing me to speak. Appreciate it.
Thanks, Craig, for the feedback. We appreciate it. Next up, we have Frank Capone. Frank, I'm unmuting you. Go ahead and unmute yourself and begin your question.
Hi, I just wanted to support what Craig just said on the instantaneous monitoring and the leaks. More often than not, in my experience, and I did this for 40 years, is surface leaks are usually surface cracks in the cover that are easily remediated. You don't have to walk circles to find others. But what you do is integrated monitoring. If you have elevated integrated monitoring, it indicates a more widespread problem. And that's the reason we do integrated monitoring, because of that. So if it's an isolated, say, I'll use 300 ppm or 500 ppm hit, and there's no integrated exceedances, it's a strong indication that it's something like that, a surface crack or something along those lines. And you don't need to be searching for other stuff, because once again, your integrated monitoring would have picked up a larger scale problem. And as far as the integrated monitoring goes, there was a comment that from your staff that that the data shows that it shifts to other areas. I'm hoping you're going to provide that data. I sure would like to see it, because in my experience, that doesn't happen. So thank you.
Thank you, Frank. We appreciate it. John Borrego, you're up again. I'm going to unmute you. Go ahead and unmute yourself and start with your question or comment.
Hi, John Borrego with Yolo County Landfill. I think that specifying a pattern for finding these instantaneous leaks isn't necessarily the way to go. We already do, staff are already searching around to find where the high point of the leak is anyway and how big it is. It's more, I think, a question of asking that we report those findings in our reports. Right now, all we do is we list, oh, this grid had a 500 exceedance on this day and this time, and the map shows a red dot. I think what you guys really will want is a little more of a report of that area. And and the area we found was, it was a crack, or it was a broken pipe, or it was this 25 square foot area. Whatever it is, I think that's more what you guys are looking for, rather than, because we're already going around to find where the high point is, because so we can actually fix it. So I don't think specifying exactly how to find that would be helpful. And then on the integrated remonitoring stuff, yeah, I don't think doing the surrounding grids would be helpful. We do not see the integrated areas moving around too much unless there is some broader problem. And so, and I think that's one of the things that the person from the EPA brought up a while ago, saying that they're, in some places where they're having right at the wells, surface emissions problems. In general, for us, that indicates a bigger problem with the gas collection system and not necessarily the spot right there to fit. I mean, you fix that little spot, and if it's still a problem, then you have a bigger problem. So anyway, thank you.
Thanks again, John. Next up, we have Jennifer Elkins. Jennifer, I'm going to unmute you. Go ahead and unmute yourself.
Hi, I just wanted to touch base on the comment made earlier about the financial burdens to landfills. And I'm not willing to go off the honor system of landfills self-reporting and voluntarily reporting methane emissions or anything like that, because honestly, I do live in a neighborhood that is heavily impacted by a landfill. Had to take our own measures to protect ourselves because of the landfill not reporting their emissions and hiding the truth. And so while I understand it may be a financial burden, I think it's well worth it to protect the environment and the residents. And in the long run, it's better. Not every landfill is bad, but you know, there's landfills out there that are not running things the way they should, and we need to be able to find those problems and fix them before it becomes a bigger issue like it is in my community where people are getting sick.
Thank you, Jennifer. And we have time for one more question if someone wants to raise their hand.
I think we're good. Okay, let's go ahead and move to the next topic. Okay, so now we'll talk about SEM frequency. For closed landfills or inactive areas on an active landfill, the current regulation allows surface emission monitoring to occur annually rather than quarterly after 4 consecutive quarterly monitoring periods with no exceedances. Staff is considering requiring quarterly monitoring in all areas of all landfills. Research has shown significant seasonal variability and intermittency associated with landfill methane emissions. In addition, closed landfills can experience settling and erosion over time as waste breaks down, which can compromise wellbore seals and other components. And compliance inspections often find leaks at landfills that had not reported any exceedances for multiple years. So, more frequent monitoring would create additional mitigation opportunities and reduce the chances of leaks persisting for up to a year. So, what do you think about this concept? Are there alternatives we could consider? Please raise your hand in Zoom if you'd like to provide feedback.
Hello, Catherine Blauveld again. So I'm going to unmute you. Go ahead and unmute yourself and begin with your question.
Really excited to see this attention to frequency again. And, you know, we have heard it from all parties, although from different perspectives. Landfills are very dynamic. They do not emit on a quarterly basis, obviously. So I wanted to, as I read this, the spirit of this is let's continue comprehensive and do comprehensive monitoring at all landfills across the entire landfill. That would be a big upgrade. And again, there's a mountain of evidence at this point that there simply is more methane being emitted than we're catching. I do want to offer other idea, which would be monthly monitoring, monthly comprehensive monitoring. And certainly you could do a greater frequency than that, but the quarterly, considering the evidence from your own air flights and research demonstrating that when there are large methane plumes, they are persistent. They can even be on average larger than oil and gas plumes detected. That really calls into question, right? Are we catching those very large emissions in time? So please consider a more frequent monitoring for both active and closed landfills. And that would just be, again, to fulfill your mission on effective methane mitigation, a really important building block.
Thank you, Catherine. And Quinn, how are we looking on our schedule?
Yeah, I think it's probably about time for us to take that 10-minute break. So I'm going to go ahead and call it now. We can come back at 2:50, and I will see you guys back here then.
I want to appreciate or let everyone know how much we appreciate the comments and the discussion today. We still have a lot of material to get through and a hard stop at 4 o'clock. So we hope to maximize the comments as feasible, but we're going to prioritize getting through the material that we have left. And I want to encourage all of you to submit written comments to the public document that will be open today at 4. So with that, I'll pass it back to Quinn.
All right, thanks, Matt. So moving on to the next topic. Gas collection and control systems are complex. They consist of numerous components extending throughout and across the landfill property. Component leak monitoring is required on all components containing landfill gas under positive pressure. Common leak sources include components like valves, sampling ports, pumps, flanges, gaskets, and connectors. These are places where leaks are frequently found, and it's important that they're surveyed every quarter. We're considering requiring operators to develop facility-specific component leak monitoring and repair plans that cover all components. Similar to the oil and gas, the leak detection and repair provisions required in the for oil and gas sources under the Oil and Gas Methane Regulation, excuse me. So the plans for the oil and gas sector include monitoring procedures, site maps, lists of equipment and components to be monitored, monitoring frequency, and repair timeframes. Preparing plans like this would ensure that the operator has assessed which components are required to be monitored, and we also believe that planning documents are useful to guide personnel performing component leak monitoring with consistent and complete information. So with that, we'll open it up for feedback on component leak monitoring plans. Please raise your hand if you'd like to speak. And again, we're going to keep the number of commenters limited, but go ahead.
Thank you, Quinn. We have a raised hand from Michael Caprio. Michael, I'm unmuting you. Go ahead and unmute yourself and begin your question.
I'm good, John. There was a sleight of hand there. Thank you.
No problem.
Okay, and we'll go ahead and move on to the next topic. Under the Federal Clean Air Act, US EPA can issue emission guidelines for existing sources that must be implemented by states through what are called state plans. The emission guidelines for municipal solid waste landfills were last updated in 2016. CARB submitted California's state plan, demonstrating that the LMR is more stringent than the federal requirements, and agreed to supply our annual LMR reports to US EPA to comply with the emission guidelines. However, US EPA identified that the LMR lacked some requirements for wellhead monitoring. In 2021, US EPA issued a federal plan that includes those wellhead monitoring and reporting provisions. We're considering adding the additional federal requirements to the LMR that are related to wellhead monitoring, record keeping, and reporting. These include provisions about wellhead operations and monitoring of gas temperature, nitrogen or oxygen concentrations, and both root cause and corrective action analyses. The specific provisions in the federal plan are listed and linked on this slide, and our concept at this point is to add all of those provisions to the LMR. So we'll now open it up for any questions or feedback on potentially adding these wellhead monitoring provisions from the federal plan into the LMR. Please raise your hand if you'd like to give a comment or ask a question.
Thank you, Quinn. John Borrego, I'm going to unmute you. Go ahead and mute yourself and start.
Hi, John Borrego with the Yolo County Landfill. Since we are under the volume threshold for some of the Part 62 requirements, would those be included in the LMR also, or would we get pulled into all those requirements that we currently do not have to do? And would others in our similar situation be in the same thing? That's my comment. Thanks.
Yeah, John, thanks for that question. I think it's a good one and one that we're interested in hearing your feedback on. As you probably realize under the LMR, we don't make distinctions other than, landfills that need to be controlled and not controlled. We don't have different sets of requirements above that once you are required to install and operate a gas collection and control system. So our initial thinking would be to apply the same wellhead temperature limits and monitoring requirements from the federal plan and make that applicable to all landfills that operate a GCCS. So if you want to provide feedback on that, we appreciate it.
Okay, Tamiko Endo, I'm going to unmute you. Please unmute yourself and start with your question or comment.
Hi, thank you so much for putting on this presentation. And I would just like to say I should have stated I work with the Bay Area Air Quality Management District. And if you were to include the federal plan requirements in the LMR, it would save our district and probably many districts a lot of work with Title V permitting from having to cite both the federal plan and the LMR, and would be great staff savings for us. Thank you.
All right, thanks. Okay, so that concludes our concepts on monitoring. We'll now switch gears to concepts for potential changes to operational requirements. Under the LMR, individual gas collection wells can be disconnected from vacuum for specific activities, like well raising and certain construction and repair actions. Currently, operators need to report that downtime if it exceeds 5 days at any well. The regulation requires operators to implement procedures to minimize emissions during downtime, but does not specify what procedures are acceptable. LMR reports show long periods of well downtime at some landfills for active filling or construction, sometimes for several months, suggesting that wells may be disconnected for longer than necessary to perform these activities. The airborne remote sensing surveys we described at the beginning of the presentation have shown that the most commonly identified cause for leaks was collection system downtime. In most cases, this occurred at the working face to allow for filling and well raising activities, or in an area where construction was taking place. This slide shows the leak causes identified by operators in the airborne surveys, as I just discussed. It shows that 43% of the leaks were identified to be the result of gas collection system downtime, more than any other single category of leak cause identified by operators. Other recent research has shown that the working face accounts for a significant portion of total emissions at active landfills. We're considering several changes to minimize collection system and well downtime, and to reduce emissions during periods of unavoidable downtime. These are informed by best practices employed by some operators, and they include reconnecting wells to vacuum at the end of each workday to ensure that the wells are collecting overnight, requiring mitigation measures be used for component downtime longer than some set time limit, and listing the allowable mitigation measures, limiting the number of wells that can be disconnected at one time, similar to requirements in some local air districts, and limiting the size of both the working face and construction areas. We believe that employing effective mitigation measures, together with the previous monitoring concepts, has the potential to significantly reduce emissions from operational activities and disruptions. Okay, we'll open it up now for feedback on addressing gas collection system downtime. Please raise your hand in Zoom if you'd like to speak.
Thank you, Quinn. Craig Cecil, I'm going to unmute you. Excuse me. Go ahead and mute yourself and start with your question or comment.
Thanks again, Craig Cecil, Butte County. Again, this one seems like you guys really don't understand what's going on in an active landfill. When a well's typically raised in an active area, somebody puts a 10 to 20 foot stick up on that well. because that's what's being filled around it before the wellhead can be put on. So I'm not sure how safely somebody could be lifted 10 to 20 feet up in the air to reconnect a well at night, or even drag the lateral or back out to that area to reinstall it. So it seems a little odd that that would be a suggestion. I could understand though, maybe shortening the time that a well has downtime, but again, in our situation, we're not like Orange County or LA Sanitation District or something that does 15,000 tons a day. We do about 600 tons a day. So when we're opening up a new cell or module, uh, it takes us sometimes 10 days to get a level high enough in that area to move on to the next fill sequencing. So because our trash, the amount of volume of trash we take in is so minimal. So to have us put it back online in 5 days and move is really not operationally a sound idea. I understand, again, in an area where you're taking in 10, 15,000 tons in a day, there's probably a lot more methane being emitted than a small landfill that we oversee. So maybe again, this was one of the ones that should be situational and relied upon the local air district to provide guidance in that aspect. Thank you.
Thank you, Craig.
All right. Thanks. Moving on to gas collection system operating parameters. So maintaining a steady level of vacuum to pull gas through the GCCS is important to achieve a high gas collection efficiency, to avoid odors and surface emissions, while also avoiding excessive vacuum that can lead to air intrusion. Changes in applied system vacuum could indicate potential issues within the gas collection system, like impaired wells. Significant changes could decrease the effectiveness of the gas collection system and could bias surface emission monitoring results if those surveys are performed when system vacuum is abnormal. Under the current regulation, well pressure monitoring and tuning is performed monthly to ensure all wells are maintained under vacuum. For gas control systems, continuous monitoring is required to ensure that operational parameters are maintained within their tested ranges. But there's no analogous monitoring for collection systems. So we're considering requiring installation of a continuous pressure sensor to monitor system vacuum. Under this concept, landfills would be required to establish a normal operating set point for system vacuum. The system vacuum would then need to be maintained within a range of that normal set point. And any periods outside of that range would need to be reported. So the reporting could include the date, duration, and reason for the change. All right, what are your thoughts on a requirement to monitor and maintain a consistent system vacuum? Go ahead and raise your hand now.
Andrew Wayne, I'm going to unmute you. Go ahead and unmute yourself and begin with your question or comment.
Andy Wong from WSP, former Golder Associates. So setting a header flare station inlet, lower inlet vacuum point with a relatively narrow range probably doesn't compensate well for diurnal barometric pressure changes, plus storm or wind or whatever else affects possibly that. I mean, I guess you could do it on an absolute gauge pressure base, absolute pressure basis versus a gauge pressure basis, but I think there's a problem with holding constant vacuum all the time. We see that when we try to hold a constant vacuum on a landfill with a variable speed controller on the blowers. So there might be unintended consequences for doing that, especially including overpull at nighttime when the barometric pressure is high and air wants to push in through the cover. That's it.
Thank you, Andrew.
All right, thanks for that comment. Repeated surface emissions exceedances from the same area of a landfill may suggest inadequacies in the collection system, insufficient cover thickness, ineffective cover materials, or issues with other components. Additional focus might be needed in these areas to prevent further exceedances. In response to recurring leaks, we're considering adding new requirements for landfills with a high number of SEM exceedances in a single monitoring grid. Maybe 10 or more initial instantaneous exceedances or 5 or more initial integrated exceedances in a single grid over 3 years. Under this concept, the operators would need to increase monitoring frequency, conduct an assessment of the landfill surface cover and the components of the collection system, and remediate any issues identified. So we'd like to hear your thoughts about this. How could we, define sites with persistent emissions or add details to those response requirements? And of course, we can always take feedback at the end or in written feedback. So I'm happy to receive feedback that way as well. I will go ahead and move to the next slide. Recurring loss of pressure or gas flow through the gas collection and control system can lead to increased emissions through ineffective collection. Advances in technology and data management have resulted in low-cost, readily available wellhead monitoring solutions that can provide actionable, real-time information for operators to make system adjustments or identify necessary repairs more promptly. Continuous monitoring systems have been voluntarily adopted at several California landfills. We're considering requiring sites with frequent or persistent gas collection issues to use continuous monitoring of individual wellheads and either more frequent or automated tuning of gas wells. Issues that trigger this requirement might include loss of vacuum or gas flow, or maybe high gas temperature. So go ahead and collect your feedback now. If you'd like to speak, you can raise your hand.
David Pinoyer, I'm going to unmute you. Go ahead and unmute yourself and start with your question or comment.
Hey guys, this is David Pinoyer. I'm not startled, shocked, but a lot of these requirements that you guys are throwing out here as possibilities are significant. I mean, and again, we're not shying away from burden, but I don't know. In the devil, it will be in the details as to how you propose these, and of course, we'll provide written comments. But I see some of these as being counterproductive, extremely onerous, and boxing people in and not giving us the ability to do what we need to do to properly manage these assets. So I'll leave it at that, but these are looking very, very onerous, and I'm not sure if you're going to be getting the results that you're really after. It seems like it's more just process for the sake of process.
Okay, thank you. So next we want to talk about managing declining gas generation at older closed landfills. The regulation requires gas collection and control systems to operate continuously. However, landfills that are closed and no longer accepting waste will eventually reach a point where methane generation declines enough that it's not possible to continuously operate the GCCS. There's just not enough combustible gas available. The current regulation has provisions to address this situation, including the ability to request semi-continuous operation through what's called an alternative compliance option, and a list of conditions for when the GCCS can be permanently shut down. Semi-continuous operation involves periodically shutting down the collection system for short periods of time to allow gas to build up within the waste mass. At sites with robust final cover, these brief shutdowns can increase the flow rate and methane content so that the control device is able to operate without unplanned shutdowns and without causing surface methane exceedances. Permanent shutdown is available under the current regulation if the landfill is closed, the GCCS is operated for 15 years, the surface methane concentration measurements do not exceed the regulation's limits, and the operator submits an equipment removal report. The conditions for both semi-continuous operation and permanent shutdown are not very well defined, and some air districts and operators have requested that CARB provide additional guidance for well decommissioning, semi-continuous operation, and permanent GCCS shutdown. To that end, we're considering clarifying and strengthening these criteria, including requirements to demonstrate declining gas generation and to rule out alternative solutions, as we'll show on the next slide. On this slide, we'll walk through our current thinking about the best steps to manage declining gas generation at closed landfills. When an operator identifies a decrease in gas flow rate or composition, or when parameters like low flow or low temperature cause frequent unplanned shutdowns, the operator should first analyze monitoring data and perform a thorough field inspection to ensure that the GCCS is functioning optimally. As an example, in one case, an operator failed to recognize that declining gas flow and high oxygen was due to broken or impaired wells. And once the collection system was repaired, the flow was sufficient to resume continuous operation. Field inspection could include checking for broken, pinched, plugged, or otherwise impaired collection wells, and examining the surface cover and cover penetrations like wellbore seals. Additional leak monitoring may also help identify problem areas. If low gas conditions persist after correcting any issues in the collection system, operators should work with the control device manufacturer or engineering team to determine if modifications could be made to the device to handle a lower flow rate or quality of gas, like modifying flare burners or louvers. Using supplemental fuel may also be a solution in some circumstances. If these previous steps have not addressed the issue, the operator should evaluate the feasibility of flare replacement. Flares are available that can treat landfill gas with low flow rate or low methane content. Under this concept, if the GCCS cannot operate continuously and all of the above options have been pursued, the operator could submit an alternative compliance option request for semi-continuous operation, as we'll discuss more on the next slide. And finally, the GCCS could be permanently shut down if certain conditions are met, and our concept for how to potentially adjust the criteria and process are coming up after the next slide. So starting with semi-continuous operation. The current regulation lacks guidelines or standard criteria to demonstrate that the system cannot be operated continuously and to ensure that semi-continuous operation is limited to closed landfills with very low methane generation. This results in the potential for inconsistent or insufficient criteria to be used when evaluating requests and contributes to uncertainty for operators. We're considering setting a total annual gas recovery threshold at a value that most existing high temperature flares are capable of meeting while operating continuously. The threshold would act as a guideline, allowing operators to foresee when they're approaching a point where they may be eligible for semi-continuous operation. That would help avoid the repeated unplanned flare failures that are typical current indicators. Operators would then take the steps illustrated on the previous slide to ensure that the semi-continuous operation is the only viable option and demonstrate that the site would remain in compliance with all state, local, and federal requirements under the proposed alternative. The alternative compliance option request would also need to specify a process for increasing or decreasing the GCCS operational time in response to gas parameters and control system performance, and propose a minimum operational schedule. Now moving on to permanent shutdown. Currently, the LMR lists 3 criteria for permanent gas collection and control system shutdown. The first is that the system was in operation for at least 15 years. But landfill gas generation varies significantly depending on the landfill's size and other conditions. Some landfills generate significant quantities of recoverable methane for several decades after closing. In our previous workshop, we showed the projected gas recovery for a landfill in California that closed in 1990 and is projected to continue operating its control system through 2060. Therefore, we're considering applying a measurable methane emission threshold for removal based on the methane collection rate. Demonstration of collection system functionality would also need to confirm that low methane collection is the result of low methane generation. Next, the LMR requires that there have been no SEM exceedances, but does not specify any details like a time period. So we're considering specifying a time period before and after shutdown to demonstrate that the system has been operating without exceedances and will continue to do so even when the gas collection system is no longer operating. Finally, the equipment removal report is a notification that does not explicitly give regulators the opportunity to evaluate whether all removal criteria have been met. We're considering requiring operators to instead submit a request, including documentation showing that the prior conditions have been met. Removal requests would also need to demonstrate that compliance with other rules, regulations, or requirements would be maintained. So we'll pause now for questions, for your thoughts on these concepts to manage declining gas generation. Go ahead and raise your hand if you'd like to speak.
Thank you, Quinn. We have Nick Lapis. Nick, I'm going to unmute you. Go ahead and unmute yourself and start with your question.
Hi, Nick Lapis again with Californians Against Waste. I think these concepts make a lot of sense if they are paired with the stricter monitoring of closed landfills. I actually raised my hand earlier to comment, but then we went on break and you guys didn't get back to me. I wanted to echo the earlier comments from Catherine Blauvelt about looking at monthly monitoring for closed landfills. And the reason I say this is not just because monthly is shorter than quarterly, but because if you look at the actual situations we've had in California, we have seen old closed landfills that did not have issues for many years suddenly become major sources of methane. And we think of the Berkeley landfill that closed in 1983 and became a major source of landfill emissions in the past couple of years. Which actually raises one other point that I think might merit inclusion in this consideration, is the geographical nature of the landfill. One thing that we've seen, and this is true with the Berkeley landfill and several others as well, is that the landfills are located in tidal zones that are increasingly facing sea level rise and in general have direct access to the water, are the ones that tend to restart their gas generation. And so the requirements should probably be different for a tidal landfill than one that's in the high desert. Thank you.
Thank you, Nick.
All right, not seeing any more hands, so we'll go ahead and move on. And the last section of concepts relates to potential changes to applicability, reporting, and other miscellaneous items. Some landfill gas control systems and devices are owned or operated by third parties. So what we mean by that is it's a different entity than the owner or operator of the landfill. Under the current regulation, a person or entity who owns or operates stationary equipment for the combustion or treatment of landfill gas is considered an owner or operator, provided they purchase the gas from the landfill. This creates a situation where regulators cannot determine applicability of the regulation except by requiring submission of market-sensitive information, like purchase contracts, to confirm whether the landfill gas was purchased. We're considering revising this to ensure that all landfill gas control systems, regardless of ownership or operational control, are subject to the LMR's monitoring and reporting requirements by changing the definition from purchases to receives landfill gas. This is important because if stationary equipment for the combustion or treatment of landfill gas were not subject to the LMR, they would not otherwise be required to conduct leak monitoring and ensure control devices achieve 99% destruction efficiency. For landfill gas that's upgraded for injection to the common carrier gas pipeline, for dispensing to vehicles, or that's converted to another product or fuel, we're considering whether there's a need to clarify monitoring and reporting requirements. Now we'll take questions and feedback on third-party gas control system operators. You can raise your hand now.
Hello, Craig Cecil again. I'm going to unmute you. Go ahead and unmute yourself and start.
Yeah, I'm not sure I understand what you're saying with this one, because we do operate, as you're explaining, we have a third party generation facility on site that makes 2 megawatts off of the gas that that is being generated on the landfill. And they do have a permit to operate from the local air quality management district that requires them to do source testing, and which is what you're saying they're not doing. At least that's what I got out of this, which is false. They are held to the same leak testing requirements under their permit to operate. So I'm not understanding, maybe other areas don't have this in their air district, but I know for a fact the one that's on our facility does. And so I'm not understanding why you'd add something that's already being done under a local air permit.
Yeah, you hit the nail on the head there, Craig. Glad to hear that that's the case in your district. We've seen that it's not the case elsewhere. Even where source testing is required, districts don't always require the leak monitoring that we think is also really important for those facilities.
All right, thanks. Go ahead and move to the next topic. So one option to help improve the operation of gas collection systems is to use advanced wellhead monitoring systems and automated tuning that adjust system parameters in real time based on actual measurements. We've observed that landfill operators in California are increasingly installing these technologies. Real-time monitoring can identify when parameters go outside of normal ranges and alert operators to sudden changes. This provides information to operators who can then quickly respond to prevent or address issues and improve the system's functioning. After installing these systems, operators have shared that they've increased their rate of methane capture, reduced system downtime, and improved visibility into when and why gas collection system disruptions occur. So we'd like to hear your thoughts about how to best harmonize our regulation with advanced wellhead monitoring and automated tuning systems to encourage their use. Okay, we can, oh, go ahead.
Hi, Craig. I'm going to unmute you again. And you may begin.
Yeah, sorry, I'm the only one speaking. Craig Sissel again, Butte County. Something that we actually entertained this idea at one point. The thing that stopped us, one was the initial cost of it. And then we keep talking about offsetting carbon emissions. And to make these products that are going on the wellheads, you're creating an additional waste stream that's not necessary right now. You've got solar panels, batteries, computer systems, different control systems. So we looked at it as similar to a lot of people right now that get solar panels on their houses. Where is that waste stream going to go in 10 or 15 years? We don't have an industry that's ready to accept that. Similar to this type of stuff, all of a sudden we would have a waste stream because it's not a tried and true, it's a tried industry. It hasn't been used for 20 to 30 years. So in maybe 10 or 15 years, you invested $200,000 in this technology, you're going to be removing it. And now you've got a waste stream that you're going to have to get rid of and replace it with something new, which is going to be an additional cost. So to us, and we also have as I mentioned earlier, we have a waste generation facility on site. So we have a contract with a environmental contractor to come out here twice a month to do tuning on our well field. So that kind of would negate the cost for putting that in, since he already basically balances our well field where it doesn't take very much tuning at all. Maybe he cracks a well 1/10 or 2/10 of an inch once in a while, but for the most part, our well field is pretty stable. So yeah, that was what if you have a really good technician out there doing your well adjustments, they're doing what this technology really already does. The only thing you're getting a benefit out of this is maybe real-time data to say, oh, look what my well field's doing right now. But it also is basically what it's doing already when he's getting that snapshot twice a month. So cost was overall that cost, and then the additional future waste stream is what stopped us from putting it in.
Thanks, Craig. Next up, we have John Borrego. John, I'm going to unmute you. Go ahead and unmute yourself and start with your question.
Hi. So we do have the automated thing going, and even in our system, which we, is similar to what Craig was talking about, spent a lot of effort manually tuning it or whatever. As soon as we switched over to some of the automated stuff, we saw an immediate increase in gas collection and system efficiency, around 10%, without doing anything other than having the wells adjust themselves several times a day. So now costs are a big issue. The arrangement we have with folks who install that is not costing us anything right now due to tax credits and other sorts of gas collection credits and things like that. But that's not an option for everyone. But to the point that costs are an issue. So I'm a big fan of the automated wellhead tuning, but it's not for everyone, I don't think. That's all. Thank you.
All right, thank you. Okay, we're about to move on.
Your conference is ending now. Please hang up.
Okay, we'll see if we can keep going. On to the last topics here on reporting. The LMR specifies what information must be reported to CARB, but it does not include details about the format of that information. We typically receive annual reports by email as PDFs with no standard formatting. Operators frequently omit required information and sometimes provide voluminous records that are not required under the LMR. Tracking the receipt of hundreds of reports and extracting data to evaluate compliance requires significant staff resources. We're considering requiring a standard electronic format for all annual LMR reports. We think that much of the data that's reported is best suited for a fillable form, similar to existing voluntary reporting templates that are available on our website. For some records, including surface monitoring results and landfill maps, we're considering requiring data to be submitted as a geospatial file to enable easy visualization. Other supporting documents like narrative descriptions of corrective actions could continue to be submitted in PDF format. We're also considering simplifying reporting by building validation checks into the reporting system that would identify potential errors and omissions. So we'd like your feedback on how to best implement standardized digital reporting and improve clarity and efficiency for both operators and regulators, but we'll take your feedback after the next slide. I'm gonna also do the other reporting slide. So through over a decade of implementation experience, we've identified various potential clarifications and changes to reporting parameters that would help to evaluate compliance with the regulation and improve our understanding of the causes of methane emissions. Some concepts introduced throughout this presentation would also require new reporting parameters. So our last concept is to update reporting and record-keeping parameters. We've reviewed reporting requirements under other relevant programs to inform some ideas of reasonable requirements, but we want to hear from you on what reporting and record-keeping parameters could help improve oversight and transparency. So I'll now open it up to feedback on both the reporting process as well as potential parameters. You can go ahead and raise your hand now if you'd like to comment. Okay, so we'll go ahead and move into our open discussion then. So thank you everyone for sticking with us through that very long exploration of potential changes to the landfill methane regulation. We'll now begin our open discussion. So this is the final chance to revisit any topics or from our concepts or areas for potential changes that we didn't identify. And of course, you also have the opportunity to submit written feedback. So we'd love to hear your written feedback as well. We've put the instructions back up for raising hands, emailing questions and comments for those who called in or are experiencing technical difficulties, and the link to where written feedback can be submitted. So go ahead now. You can call on hands, Sean.
Thank you, Quinn. Jennifer Elkins, you're up. I'm going to unmute you. Go ahead, unmute yourself and begin.
Hi. Again, I'm Jennifer Elkins. I'm a Valverde resident living near one of the impacted landfills that gives out a lot of emissions. And I just want to remind everybody that CARB is supposed to protect human health. I think it's important to hear from residents and those who are actually impacted by the decisions that you make. I would like to suggest that you hold a hearing in a community that is currently impacted by landfill emissions. And I invite CARB to come to my community in Castaic, California, to speak with impacted residents and get their feedback. The landfills are getting a lot of time to share their opinions and concerns, and I feel that impacted residents deserve to be heard as well, as we are the ones dealing with the consequences of mismanaged landfills. Again, there needs to be oversight, and we cannot rely on landfills playing by the honor system to report on things like methane emissions. So those are my suggestions, and I will also submit some written feedback. Thank you.
Thank you, Jennifer. Next up, we have Veronica Aguirre. Veronica, I'm going to unmute you. Go ahead and unmute yourself and begin.
Hello again. First off, I just want to thank you all for giving us the opportunity to have this space. A combination of industry, regulatory agencies, organizations like myself and community members also like myself. And as Jennifer had expressed, also being somebody that lives next to a landfill that, is also, suffering many of the terrible impacts that a landfill can bring. I just wanted to touch back with what was said from in the first part of the webinar, that not all landfills are the same, and of course not. We all get that not all landfills are the same, but we all have one thing in common, and we're all having to be impacted negatively from sources like methane, odors, and things like that. That's all the same. So it's important that we have things like mandated technology like drones and things like that, although sometimes it does seem costly or maybe not even necessary. But the reason why, and I'll go back to what Mr. Capone had said, that some operators operate correctly and they're paying for others that don't. Well, unfortunately, that is why then it's necessary to have things like drones and systems like this mandatory to to make up and hold those that aren't operating correctly accountable. And I think that's why I need to express and stress, as somebody that lives very close to a landfill, as who has family members, who has friends and people in my community, it would be wrong for me not to express the fact that I think that it is very important to include that in this and make it mandatory. And again, I understand, I do not work at a landfill, so yeah. And I guess maybe I had to look up on Google what a desk jockey was. And I guess I am I work at a desk, but I also live next to something that's a source that is harmful to those in my community. And part of my job is to also express that, because we hear it daily, we live it daily, and we need to get that across, that there needs to be more stringent policy. There needs to be a mandatory issue that they need to follow. So thank you again. I appreciate the time. Thank you.
Thank you, Veronica. Next up, we have an online question sent to our LMR inbox, and this is from Janet at Bay Area AQMD. And the question states, have you considered adding some language about how many times the same components can be replaced under a short period of time before an alternative solution could be used, such as replacing the entire thing? We've seen some facilities have repeat problems at sources, and instead of replacing them, they make repairs that are obviously not working if the same components keep having issues. End of question.
Yeah, thank you, Janet. That sounds similar to provisions we've heard about in other regulations, and appreciate that idea and input. And I also just wanted to take the opportunity to say how much we appreciate the coordination that we've been able to have with all of our partners at the districts in implementing and overseeing this regulation. So we've learned a lot from your experience.
Thank you, Janet, and thank you, Auntie. Next up, we have Catherine Blauveld again. Catherine, I'm going to unmute you, and you could go ahead and unmute yourself and begin.
Thank you. I hope I'm coming through okay.
Yes, you are.
Really great. Many thanks to the CARB staff. I can only imagine how much work and due diligence goes into this. And we really are in a once in a climate moment opportunity. I just want to acknowledge how high the stakes are, both for the communities and folks that have spoken up on this call, and for the climate. And it is worth saying, we just really appreciate CARB taking your role as the chief regulator, setting minimum standards so communities can expect a minimum of outcomes from the landfills, that, you know, honestly, a lot of costs are being externalized to the public. And there are tornadoes in California, and there are other extreme weather events, and those are all costs that we are all feeling. So really just holding space for CARB as the governmental entity that's looking out for public health and for community and for all stakeholders, taking that into serious consideration. So I'd say with that background, I just really urge you to create a program that is 21st century, and that we see a lot of really important upgrades where you're doing that, particularly on your super emitter program. And then there are some places where it appears the status quo is holding, and really ineffective, inadequate practices are still the norm. And that is the walking surface emissions monitoring. And so just ask that in your due diligence that you really put it head to head with other approaches and layered approaches, because again, the stakes could not be higher in you guys getting this right. You are the leaders in this country now, and we appreciate that you'll deliver a nation-leading standard. Thank you.
Thank you, Catherine, for all your comments and questions today. Next up, we have Erica Parker, and it looks like you have your affiliation on here. So Erica Parker from Californians Against Waste. Erica, I'm going to unmute you, and you could go ahead and unmute yourself and begin.
Hi there. Yeah, thank you for the introduction. I just want to urge you guys to reconsider the proposed timeline for initiating a formal rulemaking in late 2025. Kind of echoing, the statements that Catherine just made. CARB has been discussing this concept since the workshop in May of 2023. And delaying the formal rulemaking for another year just does not align with the urgency of this issue, both, climate change and also the impacts to communities. I know we're discussing the LMR, but toxic air pollutants that are co-emitted with methane disproportionately impact vulnerable communities. And we've heard testimonies of this from different residents living near problematic landfills like Avenal and Chiquita Canyon. And I think some of the comments made in this webinar have been kind of minimizing their experiences. And I just want to uplift them right now and just really give them kind of space to talk about what they're experiencing as a result of landfills that are mismanaged, and a result of ineffective, regulations. And that's what we're here to talk about. And a faster timeline really is necessary to mitigate these harms and demonstrate, your commitment to addressing climate change and protecting air quality. And then lastly, I just want to flag that we would have liked to see something on landfill operations, like banning leachate recirculation. That's often used to increase decomposition and stuff like that. I don't think this was mentioned in this workshop. and wondering if you guys have plans to do anything on that in the future.
Thank you, Erica. Next up, we have Brayidna Mahaber. Excuse me for that mispronunciation of your name. I'm going to unmute you and go ahead and unmute yourself and begin your question or comment. Or comments at this point. Thank you.
Thank you, and no worries. Good afternoon, Christina Mohabir with California Environmental Voters. I just want to say thank you to staff, first of all, for putting on this workshop. It's coming at a really critical time. I want to echo the comments of CAW, Coalition for Clean Air, and RMI. I think we're really hoping to see the incorporation of best practices that allow for more effective and more ambitious methane mitigation, especially as the LMR is really in need of an update. And we also look forward to CARB staff's commitment on working on dairy methane in the new year as well. Thank you.
Thank you very much. Next up, we have Christine Wolf. Christine, I'm going to unmute you. Go ahead and unmute yourself and begin your question.
Hi, thanks for putting on the workshop today. Really appreciate it. I'm Christine Wolf. I'm with Waste Management. And this is really the first time that we've seen the concepts in detail that CARB is considering for the rulemaking. So we want to be able to provide sort of robust and thorough feedback on all the questions you put forward today. And so hoping that we have maybe a little bit of additional time to do that beyond the January 15th date that was included in the notice, maybe sometime in mid-February, just so we can make sure that we're providing feedback both based on sort of our best practices that we've seen, as well as understanding sort of the overlap between some of the federal and district level regulations with LMR. So would appreciate some additional time on providing feedback today, but really want to thank you for giving us specific recommendations to respond to.
Thank you very much. We appreciate the feedback. Next up, we have Ruben Rodriguez. Ruben, I'm going to unmute you. Go ahead and mute yourself and begin.
Yes, thank you. Can you guys hear me?
Yes, we can. Loud and clear.
Awesome. So I just piggyback on some of the comments that were made, and I understand the importance of these regulations and these rules, right? But they're only effective if you guys are actually staying on top of these enforcements, right? So I'd just like to highlight some issues again that are happening within our communities. And again, I take it back to the Avenel Regional Landfill. So between June 2007 to September 2022, there was a total of 230 documented complaints that were submitted into the San Joaquin Valley Air Pollution Control District. Out of these 230 complaints, only 12 of these resulted in a confirmed report, with only one notice of violation issued within this 15-year period. That is an embarrassment. That is a complete embarrassment. So a notice of violation, the purpose of a notice of violation is to initiate corrective actions that will stop the violation and reduce air pollution. Notice of violations may result in monetary penalties of up to $1 million per day per violation, according to the California Health and Safety Code, Section 42402. Serious or repetitive violations that show blatant disregard for the law and for public health may lead to criminal prosecutions. I just mentioned 230 reports in a timeline of 15 years with only one notice of violation ever being submitted or ever being granted. So again, it's beautiful to have you guys up here and talk very nicely, but the reality is the reality, and we can't run from that. So I say with the most respect and the humbleness, we got to do your job, or you have to do your job. And if you are not doing your job, then allow somebody else to step in here that will actually do their job in protecting these communities. Thank you.
Thank you, Ruben. We appreciate it. Okay, so next we have another submission to our LMR inbox. This one is from Cynthia Babich, founder and director of Del Amo Action Committee, coordinator, Los Angeles Environmental Justice Network. And Cynthia says, Thank you and really appreciate the added protections. Whether we are living on top or next to a landfill, we contribute to them and we support our community speakers. We in my community hope one day you will look at legacy landfills with no liners or capture impacting the air and future groundwater sources. And regulate, yes, with 3 exclamation points, and end of comment. Looks like we do not have any raised hands at the moment. And one more shout out for comments.
Okay, I think as we, oh, looks like we have one more.
Sure. Olivia Alaves, I'm going to unmute you. Go ahead and unmute yourself and start with your question, or excuse me, your comment.
Hi, my name is Olivia Alves. I'm a senior associate at RMI. I just wanted to reiterate how grateful we are to the California Air Resources Board for taking steps to better control planet warming methane and other health harming pollution from landfills across the state. Reducing methane emissions from landfills is one of the most immediate and cost-effective climate wins that we can achieve together in this decisive decade. There are readily available solutions to better monitor and control landfill methane pollution, and California can lead the nation by developing an ambitious and comprehensive regulation that incorporates all of the best practices and new technologies. I want to reiterate that we're really excited about what you've been considering around the remote monitoring program, continuous monitoring of the system vacuum, component monitoring, and addressing the full extent of leaks. We encourage you to also include in your proposed rule additional requirements for routine monitoring with advanced methane detection technologies like drones, automated well tuning, monitoring, and management plans for the work phase and cover to minimize surface emissions. We urge the board to move strongly and swiftly to develop protective standards. Thank you so much for your consideration and work on this topic. We will follow up with you and are excited for the opportunity to submit written comments. Thanks.
Thank you, Olivia. And thank you everyone who has commented today and hung with us for the last 6 hours or so. I think this has been a really productive discussion, and we're very, very grateful for all the feedback that we've heard. We welcome your continued input and participation, both in terms of what we've presented here and also within what we can do within the scope of our authority to improve lives for communities most impacted by landfills, living near them, and we can continue that conversation. So in terms of next steps and submitting comments to the docket, January 24th is the deadline for that. For anyone who is requesting more time, this is our contact information. This team is available to engage beyond that. We're looking forward to working with you and hearing about your suggestions for how we can make this a more robust and inclusive process. So thank you again, and this concludes the workshop.